classical physics, they're talking about. I don't even know what they mean. Why think that in Newtonian mechanics you can measure something and not have an effect on the system? I mean, you measure something, you interact with it, there are forces, there's action and reaction. Of course, if you do something as simple, I mean, a simple example everybody will understand. I have a glass of water in front of me. I want to know what temperature it is. Okay, so I take a thermometer and I stick it in, and I wait for the thermometer to equilibrate, right? The mercury goes up and eventually it stops.
The thermometer itself.
Is that number the temperature of the water when I put the thermometer?
No, it's with the.
Why not?
The thermometer.
Because there was an interaction between the thermometer and the water.
Yeah.
Typically, the thermometer is colder than the water, and therefore the temperature it arrives at is going to be a bit lower than the temperature the water was. Now, of course, if I'm very clever, I can, because the thermometer is self-measuring, I can know.
Okay. Seems to be fine. Okay. Let's go. So as you can hear, I've been listening. Let's look at the history. I'll show you.
Down or different. We'll repeat this procedure.
Yeah, I don't want to listen to Veritasium. Even though I think he's got it right. I mean, he's presenting bells. Has AI already hit the wall? What dress we are. So before I show you anything, let me show you. I've been listening to a lot of Tim Maudlin. This guy, Tim Maudlin. He's a philosopher. He teaches philosophy, but he is the best physicist I've ever heard. Like his what's the word? Exegesis, his contemplation, his analysis, meta-analysis of science and physics is so far the best. Just the best. Having said that, let's see what's going on in the news. Maybe we'll listen more to Tim Maudlin together. It's very important that we listen to Tim Maudlin together. So he says, he was asked, like, what are we never going to understand? I was sure he was going to say, oh, quantum entanglement. That's like, we're never going to understand it. Instead, he says, I think we're never going to understand consciousness. Consciousness. All right. So I wrote in the comments, talk to me. Talk to me and I'll explain to you, just a little bit. Not, I can't disclose everything, but I can, maybe shed a little bit of light. As they say. Let me charge me iPhone. Me iPhone must be charged. All right. So let's. Are we sharing? Are we carrying? Yes, we are. Yes, we is sharing. We is very nice people. More squirrels and raccoons have been arrested than anyone on Epstein's client list. Oh my God, Elon Musk. They said he was done forever.
They said he was done forever.
He is done.
The end of this Trump
There'll be new faces, a new.
Idiots.
Taylor, it's done. Just thought I'd check in. I know that you're not used to being on the losing side. You should have voted more like Patrick's wife. Shut up, Brittany. Make no mistake, Travis is secretly happy. His brother too, albeit a little snappy, smashed the phone. It sucks to have your fuse publicly blown. I don't blame you, Kels. Oh, this could come as a shocker, but I do love women. I just think I managed to secure the finest one.
Amazing. Bringing Robert De Niro and Bruce Springsteen say they're leaving the United States now that Donald Trump. Oh my god. Oh my god. Oh my god. Oh my god. Walking by the cool kids table. Why does he look black? He's eating McDonald's? He's drinking Coca-Cola? They're all eating McDonald's? Oh my god. Oh my god, these guys are so funny. It's so good to have these guys in the White House. Whoa, what is going on? Performing in Saudi Arabia. Who's this? Jennifer Lopez. Fattest, sickest country on earth concerned. New health secretary might do something. Who says that? Elon. All right. Let's continue. Let's look again in the news. Starship launch pad. The algebra step everyone gets wrong. Probably that there's plus and minus solutions.
Wrong. And even if those students get it right, 9 times out of 10, they got lucky. They don't even realize that it is an issue. And this is, again, a very important step. And if you don't understand this step, you will get problems like this wrong. So you don't want to just get lucky to solve an equation like this. But let's see how you do with this problem. So the question is 3 minus the square root of 2m plus 2 is equal to 8. And of course, you want to solve for the variable m. Feel free to use a calculator. But if you can figure this out, go ahead and put your answer into the comment section. I'll share the correct answer in just 1 second. Then, of course, I'm going to fully explain how to solve an equation like this and highlight this very, very critical step. And if you don't understand this, you're going to have a tough time in algebra. Okay, but before we get started, let me quickly introduce myself. My name is John, and I have check out my math help program at T. That definitely helps me out. So the correct answer, well, that's an indication that you did a good job, but you...
Wow, m equals the empty set. Whoa, interesting. Really interesting. But not enough to watch a video. Ether. Conditional probability in 1 minute.
Let's see what conditional probability is. So we got these 4 people, a girl and boy nugget, and a girl and boy Roblox. And we're gonna pick one at random. Yo, it looks like we picked a nugget. Okay, so this is asking, given we picked a nugget, what's the probability?
I'm already confused. I didn't understand what's given. I like it when the AI explains it. Like when he explains it, I get lost.
Can you explain why this rule even works?
Let me show you. First off, we can try it out with the powers as 2 and 3.
So the answer here should be x to the power of 2.
He shouldn't talk. He should just listen to the AI. Anyway, what's up? I think tomorrow is the flight 6. Let's see what we got. What is this? The Tim Maudlin, The Great Rift. This is 4 months ago. Tension between relativity and quantum. See, I don't have tension between relativity and quantum theory unless he's talking about quantum. Siri, stop. Thank you. Unless he's talking about quantum entanglement. That's the only thing that I'm worried about.
Certainly 5 minutes.
I have solved everything known to mankind except for entanglement.
Certainly Descartes. Right, all through that period, Newton was a natural
The audio is terrible.
philosopher, called himself a natural philosopher. And as I like to say, everybody gets a PhD and they doctorate in philosophy. So the questions I'll be asking, why, and talking about why,
He doesn't wear a mic.
and what I usually call foundations of physics, some
He's not wearing a mic. He's probably using the laptop mic or some other mic.
people call the philosophy of physics. Get into all the cause of an event have to lie in or on its past light code, and all of its effects lie in or
Yeah, bell is important, but the audio here is awful. It's 2024 and people still ruin the lecture with bad audio and video that doesn't show the slides clearly. Yep. They are not made for you. Then who for? Who like bad audio not being able to see? Oh my god. Oh my god. It's not for you. It's not for you. Can we see the quantum tunneling? I don't care about quantum tunneling. Doesn't bother me. I only care to resolve one thing, Bell's inequality. I don't care about anything else. And even when it comes to Bell's inequality, it's just 5.6% that we're off. I just need to figure that out. And that is really bothering me. What do we got? Disaster. Musk SpaceX just declared this after China unveiled its reusable Starship.
All right, so if imitation...
Oh, I don't care. I just want to tell them disaster. I farted. And there's no way to add an emoji. That's terrible. Windows dot fart. There's no fart. Wind. There it is. There it is. The most important emoji in the history of forever. Okay, that was very important to let them know. All right, what else we got? This is really interesting, an interesting way to explain derivatives. Very interesting. How do I teach math? The ultimate guide to mastering mathematics. Israel obliterate. Okay. Notify me. This is tomorrow. Unit circle simplified master. Okay. 4 horsemen of physics. What is that? What are Hitler reacts to Trump winning. Oh my god. So what happened with the fight?
Netflix sucks. That fight sucked so bad that it has made me relog into my YouTube account after 2.5 months. I forgot the password, man. I had to reset.
Thank God. I need more React content. This is perfect.
That shit. Just a vent about how much I do not like Netflix after what I just witnessed. If you don't know what I'm talking about, somehow, I'm talking about the Jake Paul versus Mike Tyson fight. A fight that has been advertised for, I feel like, over a year.
Yeah, it's been like 6 months or a year.
Now, it's been delayed several times, but it's very popular because it's, I guess, the peak of modern day boxing. All right, back in the day, you have 2 of the best in the world, and people talking funny voices, and they'd be like, hey, why don't we have a Evander Holyfield? And they fight. All right, heavyweight fight. I ever listen on the radio or some shit. Nowadays, you have very, very famous social media stars who are maybe pretty good at boxing, but you can't really tell because they don't go against really good boxers. Again,
well, they're probably good at boxing on like an amateur level, and they're probably like top tier amateurs, but playing against professionals is totally different.
Watch up famous boxers. Okay, it happened Logan Paul versus Floyd Mayweather, and now it is happening again. Jake Paul, I think age 27, who just went up against Mike Tyson, age 58, which is illegal, by the way. As somebody said of a boxing event, there's a 10-year age difference maximum for almost every single state, except for the great state of Texas, which allowed this fight and sanctioned this fight to happen.
So you can beat the fuck out of old people if you're in Texas. That's crazy. I had no idea. Wow.
tell you right now, it shouldn't have happened. Now, all the experts would know going into this fight, this is going to be a Jake win. Perhaps a Jake knockout, because the 10 fights he's won have all been by like KO or knockout by time or something like that. And I wasn't interested, right? Until this clip. I was browsing YouTube Shorts, and I see Mike Tyson doing an interview with a child. And the child asks,
the first time, what type of legacy would you like to leave behind when it's all said and done?
Pretty normal question, I get it. You're asking a living legend. He responds,
I don't know. I don't believe in the word legacy. I think that's another word for ego. That's just some word everybody grabbed onto. That was used every 5 seconds. It means absolutely nothing to me. I'm just passing through. I'm going to die, and it's going to be over.
Oh my god, that's genius.
Yeah, there you go, little Timmy. That's it. Yeah, holy shit. It's like a 9-year-old. Yeah,
genius. Wow. So Mike Tyson's different, man. He's a stone cold killer. Right? It's not like Floyd Mayweather or Dylan Dennis or Logan Paul. It's not someone who can be bought out by money. I did not believe in my mind Mike Tyson was signing up to do this for money. I feel like he wanted to prove something. It's like a retired cop back for one last job. So yeah, fool me.
AKA the plot of every single Jason Statham movie for the last 15 years. I know that because I've seen over half of them.
Once. Shame on you. I watched the Logan Paul versus Floyd Mayweather.
Oh god.
Fool me twice. I made a video a year ago after I felt like I got scammed watching the Logan Paul Dylan Dennis fight. Yeah. Shame on me. Fool me 3 times, never get fooled again. Because then, man, all right, after that video aired, they had the weigh-in. And Mike Tyson walks up wearing nothing but a damn Speedo.
Yep.
And then slaps the shit out of Jake Paul.
Oh my god.
Now, what I did not realize is that would be one of the first and last times Mike Tyson would ever hit Jake Paul. Before
Jesus Christ. Yeah, that's kind of true, isn't it? Oh man.
Get to the fight. Let's talk about the live streaming experience, okay? Because I believe Netflix got hit with a reality check. This was the live streaming experience.
See, guys, all those people saying streaming is harder, is easier than a 9 to 5. See, it's not so easy, huh? How about that? Yeah, look at that. This is hard work, what we're doing here.
For 95% of people. So many people tried to watch this fight. Netflix clearly wasn't able to handle the server load. And so streams would buffer, they would crash several times. Just me personally watching, I had to close out, reopen. Meanwhile, people were streaming from the venue perfectly on Twitter. They were streaming on the phone. That would work great. But the issue is Netflix
on Twitter. Oh, I thought Elon Musk's platform is dying. I thought Elon Musk is going bankrupt. Oh. But Thunderfoot prophesized Elon Musk is going bankrupt. My god, what's going on? I don't understand reality. All right, enough nonsense. Why nice guys turn to sex workers. Interesting. Jedi are evil. Dave's math channel, how to be a human calculadora. Herons, okay. What else we got? What is that? Is that the J? Interesting.
So China unveiled the J-20S stealth fighter, which is one of their 5th generation stealth fighters at the Zhuhai Air Show, and they were demonstrating some of its capabilities. The one thing about the JS or J-20S that's pretty incredible is that it can coordinate with unmanned aircraft, which is going to make it a force multiplier. So China unveiled the J-20S.
That's interesting. I think the U.S. should purchase a bunch of these J-20S. Just for practice. Wow. Wow. What happened? Is he hurt? Wow. I actually once went up against an actual Olympic champion. And yeah. Whoa. That's a Mirage or something. Mirage 2000? Oh yeah, Mirage 2000. See. Drag shoot. It opened? Oh my god. Yeah, why would he do that?
If you shot a bullet at an axe, most people think it would just split in half.
Oh my god. Oh, yeah, because of the sun, it got too hot. It just
Sometimes rock climbers need to remove loose rocks that could
This is social media versus reality. First up is Yellow Spring.
Think it's gonna work?
Yeah.
Okay. Oh my god.
get offended by being.
That's amazing. He used what do you call it? What do you call that move? Uchimata. That's an Uchimata. Let me see if anybody says that. No one says.
I don't get offended by being.
Don't you know?
What Bell did? All right, let's see. Oh, 2014. No, I'm looking for something from the past couple of months. La 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 la.
Look, I've checked my findings thoroughly. Their intellect ratings are almost 20% below average.
They're all the same species. Those who live on Stratus and those who live below all originated on the planet. Their physical and mental evolution must be similar. That is basic biological law.
That's true, Spock. But obviously, the ancestors of those who live on Stratus removed themselves from the environment of the mines. Therefore, they avoided the effects of certain natural growths. Natural growths? What kind? Well, I had this Z-night sample sent up from the surface.
They have the pilot aboard.
This is one of the best episodes. Ooh, material explanation, not as weird as you think. Really?
Welcome back, everybody. Today we're going to follow up on our discussion of polarization, which we kicked off in a previous video. In order to do that, we want to examine a paradox.
The three polarizer paradox, to be specific. And so the three polarizer paradox is as follows. You have two polarizers that are 90 degrees relative to...
Wait, I know these people. They are legit. We have updated our understanding of this phenomenon. See video here.
Welcome back to Material Atomics. I'm really sorry it's been a while since we've made a video, but we are working on a book that is going to cover a lot of the information we've learned over the course of making these videos.
Yeah, these guys are legit. They've interviewed mainstream guys. I don't remember where I saw them, but I did see them somewhere legit. Not a standing wave unless got reflection. Anyway, let's hear 11 minutes.
We are also preparing a conference.
That's
We
right.
are also teaching two courses. We are also putting together a museum exhibit on contact with the extraterrestrial.
And we got 2 podcasts coming out every week at our other channel, the Demystify Sci podcast.
Which is not to say that we're busy, but we're kind of busy.
Yeah, I heard them interviewed on Universe Today, I think.
Busy, everybody's busy. I get it. Look, we have been working on Material Atomics, mostly going into this book right now. And, you know, when we were starting off writing this book, we had to wrestle with our model of light.
I think maybe about aliens or something.
And so the last video that we put out really, I think, clarified our model of light in terms of how we understand the material basis of how one atom talks to another atom using a mechanical... You're sitting down to write this book about the filamentary model of light and gravity. We had to really wrestle with mechanics of how it was that light was causing other atoms to resonate or not resonate. And this led us to our antenna model of light. So today, we want to talk about polarization because that's an extension of the antenna model of light. And the really cool kicker at the end of this video is that we're revisiting the three polarizer paradox, which is a very spooky effect, which you can see on screen here, where if you actually put two polarizers at 90 degrees, you block all of the light, and you insert a third at 45 degrees, you get more light appearing, which is very counterintuitive if you're going by the standard explanation that each one of these polarizers is screening out, you know, the light, which is appropriate to its orientation. It just doesn't make sense. So we think that our antenna model of light can solve this problem, and we're really excited to share it with you.
But before we get there,
Your antenna model, you came up with an explanation? They usually just interview experts.
it's worth doing a little bit of a refresher on what we mean by the antenna model of light, because it has been a hot second since anyone has thought about this except for us.
That's absolutely right. So let's talk really quickly about what is going on during the transmission of light. Here's an atom. Well, it's a representation of an atom. Let's say a hydrogen. It's more or less spherical, and we understand that the outer surface of the atom is the electron shell. Now, electrons have this strange property called spin 1/2, which has to do with their momentum. That is the way that the surface is turning in our interpretation. Now, we know that the way it turns is described by this concept of spin 1/2, which you can check out this video about to get a better grip on it. But an important part of spin 1/2 is that the electron is rotating, and that as it's rotating, you see that the magnetic component of that rotation is along the equatorial direction, and the electric component points towards the pole of that rotation. If you look at the black arrows here, and I rotate it in the direction of the black arrows, I'm rotating it along the magnetic field here. And naturally, the electric field points up.
I don't understand. I mean, You have a magnetic moment. It's called a magnetic moment, I think. Let me see. I have a message from. Whoa. Did not expect her to respond. I think she's fake. Like, she's too hot. Someone who's way too hot. Way too hot. I don't think she is. And the picture is obviously from the US. So I don't know. I don't know what's going on. And La 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 la. All right.
Likewise, if I rotate it,
So I don't understand. I'm already confused. I mean, this is very interesting. The fact that the shell is an electron. The electron is waving around, and it's creating a magnetic dipole. But usually, if you're saying that it's spinning around, then the magnetic dipole should be pointing up. So I don't know what you mean by all these arrows. I just don't understand. Let me hear again what he's trying to say. I usually don't like people with long hair. Men with long hair, I dislike them. But fine, we'll listen.
really quickly about what is going on during the transmission of light. Here's an atom. Well, it's a representation of an atom. Let's say a hydrogen. It's more or less spherical, and we understand that the outer surface of the atom is the electron shell. Now, electrons have this strange property called spin 1/2, which has to do with their momentum. That is the way that the surface is turning in our interpretation.
It's an angular momentum.
Now, we know that the way it turns is described by this concept of spin 1/2, which you can check out this video about to get a better grip on it. But an important part of spin 1/2 is that the electron is rotating.
Where's the video? You're not showing a video. There's no link.
Turns is described by this concept of spin 1/2.
Oh, she's responding. That's weird. This can't be real. La 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 la. That's one of the problems with apps, with dating apps. All right. So
1/2, which you can check out this video about to get a better grip on it.
Oh, is this the video? This?
Electrons have an unusual property called spin 1/2, which emerges from Paul Dirac's relativistic wave equation. Dirac believed that this property could not be physically visualized, but since this is a material world, we're going to show you a simple model of the electron shell that displays this mysterious spin 1/2 property.
Ordinarily, when we rotate simple objects with fixed surfaces, they behave in a simple and obvious way. When you rotate through a full turn, you look exactly the same as when you started. But the electron is unusual. When you rotate it through a full turn, it does not look the same as when we started. You have to rotate it through a second full turn to get it back to the original state. And that is spin 1/2.
Electrons can take two spin states, spin up and spin down. We think of these as when the shell rotates, the surface involutes up or down, as shown in these two variations here. Both models are still spin 1/2 and require rotating twice to get back to where they started. When viewed with the right-hand rule rotation vectors shown, we can see why they're called spin up and spin down, since the shell involutes upward or downward. Here are the models with their polyspinner notations.
Finally, a positron can be seen as a time-reversed electron, which just means that it rotates in the opposite direction. And here we have all four spinor components moving at the same time. And here is the Dirac bispinor notation for each of the four states.
Taken together, these four models give a simple physical...
I didn't know Dirac has a spinor notation. I didn't get to that yet. So this is up. No, this is the electron. This is the positron. So electron up is 1 0 0 0, and down is 0 1 0 0. Whereas positron is 0 0 1 0. And down is 0 0 0 1. So up is opposite. Okay, like this. Down is opposite, like that. And these are opposite like this, and these are opposite like that. All right.
View of the basis spinors for the Dirac equation.
They have a Discord. And as usual, it's a dead server. Wait. Why is this off? I don't know. Am I allowed to be in two tabs at the same time? All right. Maybe I'm confusing them with other creators.
Let's talk about speed limits. Not the highway kinds, more nature's kinds, like the speed of my voice as it passes through the air between your speakers and your ears. The speed limit of sound, some 343 meters per second in room temperature air, comes down to the displacement of one material body by another. See, the propagating sound wave has to physically rearrange the air in front of you in order to be heard, which is why the vacuum is silent and why sound travels nearly 3 times faster through water than it does through air.
But what about light? It has a speed limit too. But in the rarefied environment of the vacuum, light speed is at its maximum, not its minimum. Look at
Very loud background music.
most
Fundamental progress has to do with the reinterpretation of ideas. What?
scientists explain the light speed, sound speed discrepancies by saying that light waves aren't mechanical in nature, but they're pure energy. But in the material world, we interpret the data differently. Our analysis suggests that light speed does depend on the elastic deformation of a medium, just not exactly the medium that you're used to thinking. This is episode 2 of our foundation series for the material world. If you want to know the philosophical foundation for all the work that we're doing here, check out episode 1. If you want to know how light, gravity, and electromagnetism work, subscribe for future videos. Right now, though, there's just one big question. Why is light speed limited?
To understand why light speed is limited, we've got to start by asking, how stiff is space-time? It'd be nice if we could sit down with our good friend Albert and get some insight on the matter, but that's not on the cards. Luckily, we can get his perspective on the elastic
Why do you assume that he knows?
of space-time by translating the general theory of relativity into the physical language of a material-based science, specifically into Hooke's law.
Hooke was a 17th century polymath who studied the dynamics of a basic spring scale and realized it was possible to derive the stiffness of a material, K, by measuring the amount of deformation, X, that resulted from implied force, F. It so happens that this Hookean relationship can also be found in Einstein's field equations, as long as you know where to look.
Matter tells space-time how to curve. This is the energy stress tensor, and this is the metric, whatever. Space-time tells matter how to move. This is the acceleration. And this is, what's this? I don't know.
Space-time tells matter how to move, and matter tells space-time how to curve. Deformation of space-time is therefore determined by the force of matter and energy. So when we rearrange the field equations appropriately, we can see the parallels.
From a Hookean perspective,
So F is proportional to X with 1 over K. Einsteinian is, this is the stress and the energy. So this is the force, and this is the deformation. Yeah, okay. force. Oh, they're using the word strain like I do. So why not use stress? Matter or energy. They shouldn't use divided by. Oh, she responded. La 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 la, na 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 na. Oh, she's not in my country. Oh, it's a problemska, very big problemska. So what's the point? Um, La 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 la. La 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 la. Yeah. Strain space-time curve.
The deformation of space-time is analogous to the deformation of a spring, and the momentum of the materials involved is analogous to the force that causes that.
Momentum? Why would you call this? This is the stress. This is the energy pressure. This is the energy. Why would you call this momentum? It's energy momentum, I guess. Fine. Whoa, she's fast. Okay, at least now I know why that she's real. Okay, let's see. I shouldn't turn off the app. All right. Anyway, she's not in the country, so it's going to be a waste of time. All right, let's see.
What's left in the Einstein field equation then is the gravitational constant, which turns out to be analogous to K, the stiffness of the material that's being deformed. This measure of space-time stiffness, which isn't an exact equivalence since materials are 3D and space-time is 4D, is extremely high, meaning that if there is material between atoms, it's unbelievably stiff.
Part 1 of the Foundation series, like here, explains why we can't treat space-time as a traditional material. This calculation holds because the gravitational constant still tells us something about reality. It takes a lot of effort to deform space-time, even a little bit. Others who have asked the same question about the stiffness of space-time, like Princeton University's Kirk McDonald, have arrived at the answer in a slightly different way, but the figures still correlate. McDonald suggests the stiffness range based on classical mechanics.
What does he say? Anyway.
Like Princeton University's Kirk McDonald, have arrived at the answer in a slightly different way, but the figures still correlate. McDonald suggests.
What is the stiffness of space-time? I mean, it's. I mean, you're not the first one. But this goes back to the ether. This is the ether. This is the argument for the ether. What is the stiffness of space-time? Kirk T. McDonald, Joseph Henry Laboratories, Princeton University, Princeton, New Jersey. April 3rd, 2018, updated. You can update a published paper? A question asked at the end of the 2018 Hamilton Lecture, Princeton, Exploring the Universe with Gravitational Waves by Kip Thorne, concerned the Young's modulus of spacetime, a classical answer. The Young's modulus Y of a elastic medium. appears in the stress-strain relation. I thought I'm the only one who calls it stress-strain. I didn't know everyone refers to it as stress-strain. So this is the strain, or maybe delta L over L is the strain. Yeah, I think delta L over L is the strain, because otherwise this has units. This is unitless. And F over A, I think, is stress. Is it? F over A is stress? Such that Y has a so if it's force per area, then this must be force per area. Pressure and energy density, called PA in the SI, Pascal.
Stiffness range based on classical mechanics, quantum mechanics, and electromagnetics from 10 to the 20th to 10 to the 113th pascals. His paper is linked in the description. Intuitively, a fantastically stiff substance described by space-time makes sense, since it must be strong enough to structurally support enormous entities like the Earth, Sun, and all the other astronomical marvels. And knowing this,
What did you say? It has to be extremely stiff in order to support a marvel, whatever marvel, a cosmic marvel like the Earth? What?
makes sense, since it must be strong enough to structurally support enormous entities like the Earth, Sun, and
Structurally support? What do you mean by that?
all the other astronomical marvels. And knowing this, we can make our way back to the original question. Why does light have a speed limit? And why does it go faster in the vacuum?
The answer has to do with what we talked about in our video on gravity with the inverse square law. If an atom's electron shell extends indefinitely, as suggested by the probability density function for the electron, then these same filaments that are responsible for gravity can also host the light. Sorry, Doc, I want to stop you right there. Scientists already proved that light is simply a self-propagating electromagnetic field.
That's quite interesting. Can you tell me more about how that works?
Well, it doesn't matter.
It doesn't matter?
Field work. Scientists make extremely accurate predictions based on fields, so we know that's how much.
Yeah, they're arguing for the ether.
But nature does it.
Yeah, people don't like answering that there is a medium.
But we went over this last time, Average Joe. Fields are effects that show the intensity of some process at a given point in space.
Exactly.
There are wind fields, temperature fields, gravitational fields, EM fields. The fields tell us how much, but they can never tell us anything about the process that's actually happening underneath.
Well, that's not what it says in the textbook. What are you, some kind of misinformation
Misinformation, it's good.
spread or something?
Look, that would mean a lot more if the textbook didn't still
So he had short hair back then?
use the thoroughly discredited Bohr model of the atom.
I don't think it's discredited.
What kind of voodoo holds the little electron planet to the nucleus?
What we are proposing at the material world is that
Okay, whatever.
light is the deformation of a really stiff substance that's stretched between atoms. When scientists talk about self-propagating electromagnetic fields and light, they're just talking about the intensity of that deformation, and the concept of space-time agrees. Under this model, light speed is limited because the deformation of the material takes time. It's fastest in the vacuum then because atoms are nodes in this space-time material, and they delay, relay, or interfere with the transmission of light impulses.
I know what you're thinking at this point. How can space be full of electron filaments? Space is space, it's empty. But here at the material world, we have a slightly different perspective. We propose that space is bustling with these filaments, and we just haven't figured out a way to detect them. Remember, they are super thin, like an electron version of spider silk, which is so fragile that you'd never notice walking through a single strand of it, but the spider web does have the same tensile strength as steel.
No, almost. They almost got it right.
The electron filaments are also made of the same material as the atoms themselves, which makes detecting them
Which makes detecting them what? Very difficult?
tricky, to say the least. For the ins and outs,
No. Okay, let me just get the message from this chica bonita. So she asked me, what are you looking for? I said, I'm looking for love. She says, me too. So I'm going to say, but we are so far. La 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 la.
So that are for the last part of the Foundation series, where we're going to talk about the structure and the resonant behavior of the atom in our radial elastic model.
Remember to subscribe, like, share, and join us at Discord for discussion. We'll see you
Yeah, he had shortish hair. Still too long for my taste. But he is thin, which is good.
next time on the field.
My left and right ears are thanking you. This is a mechanism for gravity. Dublin. Undulations through a highly elastic. Oh, ether. Oh, there you go. Oh, 1837. Yeah.
Gravity. It gives weights to physical objects and guides the motion of the planets and the tides. Gravity can threaten your safety should you fall from great heights, or can securely fasten you to the surface of the beautiful planet you call home.
Gravity is one of the ways in which two separate objects and the atoms they're made of are drawn toward one another. But why? What pulls matter together?
By the end of this video, you will understand that gravity, like the rest of physical nature, can be clearly explained through interactions between simple material objects. Even better, you will finally understand why, as Newton famously related, the force of gravity falls off with the square of the distance between objects.
Most people think that the mystery of gravity's cause was already solved by Einstein's space-time construction of general relativity, where gravity is explained as a consequence of a body's motion along geodesic lines in a space-time that's curved in their presence. However, this is not the physical explanation you might think.
Space-time, it turns out, is a four-dimensional manifold where the non-spatial dimension is time. This makes it an idea rather than a surface-bound material object that's capable of cause and effect. At the end of the day, general relativity can only describe it as apparent. It does not reveal material cause.
Our explanation for gravity and the inverse square law starts with the atom. Experiments in quantum mechanics suggest that 99.999% of the surface of the atom, its electron shell, exists within 430 picometers of the nucleus. Experimentation also suggests that the remaining 0.001% of the atom's surface extends indefinitely, meaning that it can be detected at a great distance from the atomic nucleus. One way to rationalize this empirical finding is to imagine that the surface of the atom persists as thin radial filaments capable of interaction with atomic neighbors.
This allows us to consider gravity as a product of nodal atomic architecture, like that which is used for schematizing quantum computing systems, as is shown in this paper.
What? Oh, no.
As a product of nodal atomic architecture, like that which is used for schematizing quantum computing systems, as is shown in this paper.
Quantum computing. No, nothing to do. Boltzmann machines. No, that's nonsense. No.
Einstein himself foreshadowed this paradigm when he wrote that, quote, physical objects are not in space.
Physical objects are not in space, but these objects are spatially extended. This way, the concept empty space loses me. I don't know.
But these objects are spatially extended. In this way, the concept empty space loses its meaning.
Taken together, this suggests that physical interconnections.
Oh, we have Nicholas Williams with us. 1 second, Nicholas Williams, please. Oh, wait. Let's see what you say. All these videos never talk about the Planck length or fundamental factors. Everyone believes in magic or something. Oh my god. I don't know what you mean. As always, I don't know what you mean. And if they talk about it, it's passive. Then they go back to herd mentality, what everyone else says, yet still no real world explanation. They're all just repeating each other. I don't really have anything to say about that. 1 second, I have another chica bonita. Oh my god. Where is that? Oh, let me check where she lives. Let me see if it's within a formidable distance. La 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 la. La 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 la. La 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 la. Oh my god, how far? Oh my god. She's an hour away. Oh, why are they so far? She's really, really far. We could meet halfway. Meet me halfway, li 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 la, la 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 la. Yeah, she wants to switch to an app. That's a bad sign. That is a very bad sign. That's a very bad sign. Yeah, it doesn't make a difference. She's out of the country either way. All right, what do you got? Why is it stuck? What's going on? This is the second time today that this is happening. My laptop is stuck. Let me see if the transmission is stuck. 1, 2, 3, 4, 5. This is not a good sign. Oh, it's just this app. It's Brave that is stuck. Brave is stuck. You see, it's only Brave that is stuck. Can I use control? Even it's not responding to control tab. La 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 la. Alright. So I don't know what to do. Sorry about the noisy noise. This is very noisy noise. 3 people watching. I don't know what to do. Nothing is going on. Let me see if this works. La 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 la. So this app works. This suggests.
This episode is supported by 23 and
Einstein topic. And so it's so tempting to like make him the main character of the video. Like, look, he was wrong in this way.
Yeah, like this video could very easily have been about Einstein making this and predicting.
Yeah. Why is it white?
Between atoms, forged from the atoms themselves, could be responsible for the pull of gravity.
No. No. This is completely wrong. Sorry. So sorry. 65 comments. All right, let's get back to basics. I crashed out.
4 years ago, I got a near perfect score on the SAT. I was accepted to the #1 public college in America, and I was going there to study as a physics major. I was really ambitious at the time. I had big plans, wanted to go on and get my PhD, eventually go into research, and dedicate the rest of my life to studying the mysteries of the universe and all that. Now, fast forward to 4 years later, and I'm sort of a crash out. I graduated from college. I turned down the job offers I had, and then I just drove like 3,000 miles across the country from Michigan to Arizona to start a new life. I don't have a steady job. I'm doing a bit of freelance work and making some money off of this channel just to get by, and I'm in a place where I really don't know where my life is going, and I'm fine with that. But how did I even get here?
I'm glad you asked.
During my sophomore year of college, my mental health got so bad that it made me physically sick. I had all kinds of respiratory infections that just would not go away, and it even ended up developing into some kind of fungal infection that I had to go on antifungal medications for, and took a while to get better from. I had tendinitis.
I don't know if it has anything to do with your mental state.
In almost all of my joints, and just chronic aches and fatigues all over my body. It just felt like my whole body was shutting down, and I was genuinely concerned at the time that I wouldn't be able to live another year because I didn't know what was going on, didn't know why all of these weird random illnesses and injuries were just happening to me all at the same time. But this all really started when I decided to study physics in college. And looking back on it now, I realized that I didn't choose to study physics for the right reasons. The real reason why I chose to study physics in college was really because I was insecure. I was insecure in my own intelligence, and I wanted to study physics to try to prove to other people that I was smart. And in hindsight, that was the stupidest decision that I possibly could have made. What I mean by that, though, is that my whole life up to that point, I was always made to feel like I wasn't smart enough. I wasn't good enough academically. I grew up in a traditional Asian family where it seemed like no matter how hard I tried, no matter how many accomplishments that I achieved, it was just never enough. My parents never thought I was good enough. They would constantly compare me to the kids of other Asian parents in the community and just always tell me that I needed to do better. I was always taught that school and grades were the singular most important thing in life and that they would determine my success later on. And so I ended up in a place mentally where I genuinely believed that my worth as a human being was solely dependent on my academic accomplishments. So being like that my whole life, when I got to college, I chose to study physics because it was commonly seen as like the most prestigious, the hardest possible subject that you could study. And that if you're a physics major, you've got to be some kind of genius. And I just wanted people to think that. I wanted them to think that I was insanely smart. I wanted to flex that I'm a physics major at one of the top universities in the country. I didn't have a real plan for my future. I didn't know exactly what I wanted to do after college or my purpose in life, if we're going to go that deep, the things that actually matter. All I wanted at the time, again, was for people to think I'm brilliant. I wanted others to have that sort of image of me. And I fought desperately to keep up with that image because, like I said, ever since I was a kid, I was conditioned to believe that academic achievement is the only thing that matters in life and that I was never good enough, that I needed to be better, I needed to show off more and have everyone think highly of me in that regard. So long story short, I realize now looking back on it that I didn't choose physics because I was genuinely passionate about it or had some kind of plan. And I wasn't even that good at it either, if I'm being honest. At least not enough to succeed at such a high level. Because I'll tell you, when you're studying something as difficult as physics at one of the top universities in the country, in order to actually do well, you need to either genuinely have genius level IQ or have some kind of intrinsic motivation that is so deep that it drives you to to push through it and succeed. But like I said, I didn't really have either of those. I would say I'm like above average when it comes to intelligence, but I'm not actually a genius, and I didn't have the drive and intrinsic motivation either. My only motivation was kind of superficial to show people that I'm smart. So at least in my first few years of college, I was in a position where I had to work extremely hard just to barely even pass my classes in a major that I didn't care for. And it felt like there was not even a path forward at that point, because when I thought about it, I realized that even if I get through this, I still wouldn't be in a great place. If I got through my physics degree and I somehow decided to apply grad school, I probably wouldn't even get in the first place. But even if I did, I knew it wouldn't be a top school, and I wasn't confident that I would even be able to get through that grad school. And then if I didn't apply to grad school and just tried to go into the workforce, the job market right away with my
let's see this.
By the beginning of my junior year in college, I'd already finished all the required classes for the physics major. All that was left standing between me and graduation were a couple of physics electives and trying to resist the call of the void. Anyways, unlike everyone else in the major, I had to take 2 more physics electives than would normally be required. This was part of an agreement I worked out with the head of the physics department back in my freshman year as a condition to let me test out of the first year of the major. But by junior year, I was starting to regret my decision. The problem lies in the fact that most advanced topics in physics require similarly advanced math in order to understand what's going on. So many of the undergraduate physics electives in these advanced fields cut out a lot of content that's crucial to understanding how these things work, but is otherwise impossible to understand without the necessary math background. As a result, I didn't really want to take an undergraduate physics course, as I saw them as a complete waste of my time. Naturally, I thought that I should just take some math courses for my physics electives, but it turns out that all 8 of the math courses accepted as physics electives are locked behind the real analysis math sequence. Never mind that real analysis isn't a requirement for the physics major, and that the vast majority of these courses have absolutely nothing to do with analysis and can be taken with a basic understanding of calculus 3, but this is just what my university decided to do. I would say this is all a ploy on the part of my university to make me take more classes and thus spend more money to learn the same amount of content, but I'm pretty sure my academic advisor actually watches my channel. So instead, I'll say that I would have been better off listening to the career advice of the homeless vagrants that constantly accost me on my walk back to my dorm instead of listening to my advisor's brain dead takes, followed by the fact that I think the requirements might just be a scam to get more money out of me. So with physics and math courses crossed off on my list, there were relatively few worthwhile courses I could still take. One of these narrowed down choices was an astrophysics class called Physics of Galaxies. I know absolutely nothing about astrophysics and had never taken a course in the subject. I saw the word physics in the title of the class and thought to myself, how bad can it be? I'm a physics major. And so began my semester of unimaginably excruciating pain. Almost as soon as the first class began, I realized that something was wrong. The course didn't have any prerequisites, but as we went around the table to do our introductions, I realized I was not only the only non-astro major in the course, but also one of the 3 students out of a class of roughly 20 that weren't seniors. I didn't have time to mull over my fears, however, because the professor soon handed out an informal assessment to gauge her knowledge of the course material. The quiz was only 1 page long, but like the US Air Force over Dresden in 1945, I bombed the shit out of it. I couldn't even answer what a galaxy was, let alone explain how something called AGN feedback affected star formation rates. I would say that the only thing I got right was my name, but after I turned in my sheet, the professor announced to the class that because this was an informal assessment, we weren't supposed to write our names on it. So having exposed myself as a world-class moron to my professor in a class full of people I didn't know about a topic I'd never studied before, I wasn't feeling so hot. I thought about dropping the class, but there were no alternatives, and I really needed this credit. So I did something for the first time in my entire academic career. I reached out to the professor and explained that I was struggling to understand the course material. I described my apprehensions with regards to the fact that I was the only non-astro major, that I was younger than most of the class, and that I understood absolutely nothing on the pre-course quiz. She responded cordially and told me that my lack of experience was nothing to be concerned about so long as I paid attention in the class and did a little extra reading on the side. I felt genuinely reassured by her comments, and so I decided to stay in the class. By class number 2, however, I realized I had made a severe and continuous lapse in my judgment. Not only did the lecture material go completely over my head, but I realized that all the other non-seniors had dropped the class, leaving me astronomically underqualified in comparison to my peers. Equally unfortunately, it was now too late to drop the class, so I figured that I would just buy my lip and get it over with. I'm not sure how familiar you guys are with astrophysics, but the best way I can describe it is astronomy with bits and pieces of every other field of physics stuffed into it. For example, and I promise this is interesting, there are these giant clouds of gas that surround galaxies known as the circumgalactic medium, or CGM for short. These clouds are long-lived astronomical objects, meaning that they generally stick around for the star-forming lifetimes of their host galaxies. As a physicist, however, one of the first questions you might ask is, why don't they just collapse in on themselves as a result of gravity? Gravity likes pulling things inward, and because these are clouds of dust, there is no physical contact that could stop the compression. An easy explanation would be that the whole cloud spins and that the centrifugal force keeps them up, but we can observe that these clouds actually don't spin. These clouds of dust literally just sit there in the middle of space and don't fall in on themselves. If you want to take a guess as to why these structures don't implode, here's your chance. Well,
solar wind something.
According to the most recent data we have, the main reason these clouds don't collapse in on themselves is actually, are you ready for this? Supersonic turbulence. The explanation involves some knowledge of hydrodynamics, so I'll spare you the details, but pretty much the speed of sound is really low in space because of how spread apart all of the gas particles are. You might have heard how there's no sound in space. That's false. There's no sound in a vacuum because sound needs particles in order to propagate. The important caveat there is that the particles don't actually need to come into contact with each other to transmit the sounds. They just need to get close enough that the movement of one particle can force another one to move. Space isn't a perfect vacuum, however, so the sound waves can actually be transmitted by these tiny gas particles that make up the CGM. Because the speed of sound is so low in these structures, given how far apart these particles are, it's relatively easy for a particle. This video has been sponsored by Brilliant. Stick around to figure out how you can use Brilliant to learn math, science, and more, all at your own pace. Everyone in college has seen the memes about business econ exams being coloring books. I always thought these were an exaggeration, but after taking an upper-level economic statistics course at my university, I can safely say that that comparison doesn't fully capture the absolute extent of the brain rot. If you remember from the astrophysics video, by the start of my junior year, I'd already finished my major requirements, with the exception of some elective credits. I discovered that I could take graduate school courses to satisfy these elective slots, so by the time I entered my senior year, I finished a good portion of the graduate school curriculum as well. In spite of my previous track record for academic masochism, however, I decided against taking 4 graduate school courses in one semester and left one of those slots for a statistics class. Now, if you're not a physics major, this might seem like an obvious choice. After all STEM majors need statistics to run their experiments, but I assure you that this isn't normally the situation with physics. I'm being a bit sarcastic here, but it's less important what you observe in physics and a lot more important what you think you observe. For example, if you take this data, what does it look like to you? I think most people would say that it looks like maybe Shrek sneezed into a napkin, but a physicist sees this. Data is a very fickle thing in the hands of a physicist. In fact, the smartest of physicists can mold the very fabric of reality to their will, like some sort of omniscient. I once worked for a particle physicist and produced a graph of our experiment data that looked roughly like this. Pretty clear logarithmic trend, but there were 2 notable outliers. When I showed him the graph, he squinted at it for a couple of seconds before telling me to remove those points. I protested, but he, in his immeasurable wisdom, described this procedure as simply normalizing the data. That exact plot went on to be presented at one of the largest particle physics conferences in the world. Anyways, it's fairly uncommon for physicists to bother themselves with silly things like experimental design and academic honesty, but occasionally you'll find statistics rearing its ugly head in my perfect world of imaginary particles and invisible fields. To prepare myself for this inevitability, I enrolled in the first statistics class I found where the course reviews weren't telling the professor to off themselves. By the first class, however, I realized
But he said it's an econ. What is he talking about?
I made a mistake. Although the registrar had described the class as a formal treatment of introductory and intermediate statistics concepts, I realized that this was a biz econ statistics class. I'm not sure if this is the case everywhere, but my school has special classes for each subject for its special needs. I mean, it's econ students. So instead of getting geometry, for example, you would get this. In a related point, I should have probably known not to trust the registrar.
Oh, it's from the econ curriculum.
Office. These are the same people who had forgotten to let me pre-register for classes since they thought I'd already graduated. There's no excuse for this because this is a full 6 months after I'd sent them an email telling them that I was no longer graduating in 3 years. They'd also let me register for a theory of algorithms class that didn't exist. The day of the first class, I got an email from the professor telling me that she retired last year and wasn't even aware that her class was still being offered. Regardless, my point about econ majors was proven when the entirety of the first week proved to be a review of Calculus 1. One of the slides from that week had this graphic, and we were asked which one of the graphs had a shaded area of 1. It took 4 answers for someone to get the correct solution, which is wild considering there were only 3 options on the screen. That same class, the professor was describing how to do an integral of x times a function of x. The student proceeded to tell, not ask, the professor that we could take the first x out of the integral because it was a constant. When the professor tried to correct the student interrupted and said, no, like, the x is constant because f of x is changing. So, like, x is constant in comparison to f of x, so we can, like, take it out. This bickering went back and forth for nearly 5 minutes until the professor eventually told the student to meet him after class, presumably to take him out behind the math department building and put him down for being a troglodyte. Now, if you don't want to liquidate your brain like the average biz econ major, I should tell you about this video sponsor, Brilliant. Unlike my stats lecture where I had to wait for my classmates to remember the difference between multiplication and division, with Brilliant, you can control the pace of your own learning. With its huge variety of lectures made by award-winning professors from places like MIT and Caltech, you're sure to find something useful for your own life with Brilliant. One of my few IRL friends once recently told me, hey Jeff, I think it'd do you some good to stop being so negative. You might have had a point there because you can usually tell which part of the lab I've been working in each day by the amount of hair that's on the floor. This got so bad that my barber even told me.
Mm-hmm. 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 Mm-hmm.
What is the position of the Klingon ship? 100 kilometers of K7. It's just sitting there.
Captain, I have Mr. Murray.
Put him on visual.
I see.
Mr. Murray, there's a Klingon warship hanging 100 kilometers off your station.
I don't think the Klingons are planning to attack us.
Why not?
Because at this moment, the captain of the Klingon ship is sitting right here in my office.
Cancel red alert. We'll beam right down.
Security, cancel red alert.
Mm-hmm.
2 plus 2 is 4. Minus 1, that's 3. Quick maths.
3 is a magic number.
2 plus 2 is 4. Minus 1, that's 3. Quick maths.
3 is a magic number.
17 minus 23 is equal to whatever. All right. Mm-hmm. Oh, with Tim Maudlin.
Welcome to the Making Sense Podcast. This is Sam Harris. Just a note to say that if you're hearing this, you're not currently on our subscriber feed. You'll only be hearing the first part of this conversation. In order to access full episode, we don't run ads. I normally wouldn't have much to say about this, but this has been such an enormous story, at least for those of us who follow media, and everyone has commented on it, it seems. But no one has made what I consider to be the most important point about all this. So I feel like I have something to add to this conversation, which is otherwise an extraordinarily boring one. I don't know Tucker. I believe we've met twice. I think he's interviewed me twice, but populist outrage, then Tucker Carlson against you. The you being Trump's demagoguery. For years, several text messages, $750 million he felt an attack on the Capitol. On the topic of Trump skipping, Paulson wrote, "We are very, very close, incalculably less powerful, even in the minds." Let me read that final line again. He has done disregard the danger, a destroyer. It has been knows that the drug should be the end of it. I guess that remains to be seen in media, business, or culture. Professor of philosophy, physics, and logic, and his direct business has absolutely nothing and depressing about our culture, or at least a large part of our culture. But happily, this tawdry business has absolutely nothing to do with today's podcast. Today I'm speaking with Tim Maudlin. Tim is a professor of philosophy at NYU and the founder and director of the John Bell Institute for the Foundations of Physics. His interests primarily focus on the foundations of physics, as well as metaphysics and logic, and his books include Quantum Non-Locality and Relativity, Truth and Paradox, The Metaphysics Within Physics, and 2 volumes on the philosophy of physics. Tim's also been a Guggenheim Fellow, and he's taught at Rutgers and Harvard, in addition to NYU. And I reached out to Tim almost as an act of continuing education for myself in philosophy. His area of focus in the philosophy of physics and metaphysics has really not been my wheelhouse philosophically, and I had some questions I just wanted to put to him. We talk about the nature of scientific reductionism, emergence, the nature of time, causation, the nature of possibility, natural law, David Lewis's possible worlds, rival interpretations of quantum mechanics. We have a long wrestling match over the topic of free will, and such a few other things here. Anyway, Tim performed a kind of philosophical therapy for me on a few points. And also, I think we demonstrated that certain rival intuitions on the topic of free will can't quite be resolved through argument. I think I've come to that conclusion after this conversation. Perhaps there's more to say on that topic, but it just seems to me that if you experience yourself in a certain way,
I don't want to waste my time with free will and other nonsense like that.
certain points just experience can be seen any other way. I'm here with Tim Maudlin. Tim, thanks for joining me.
Thanks for having me.
So thank you for doing this. I'm very eager to talk to you that I'm curious about that I will drop on you at some point as we take the tour here, you being a philosopher who knows much more about the current implication of physics than I do. But before we jump in, how would you describe your intellectual background and the kinds of questions you focused on as a philosopher?
Well, when I was an undergraduate, I kept bouncing around between different things, and I ended up getting a degree. It was a joint degree in philosophy and physics, and then my PhD was in history and philosophy of science. And in general, philosophy and physics tend to go together pretty naturally. Probably most philosophers of science who have expertise in a science have it in physics. And I think that's because the basic philosophical impulse is always to get to the bottom of things somehow. And there's a certain sense, it's not the only sense, but there's a certain sense in which physics lies at the bottom of the empirical sciences. I don't want to say that. Sometimes physicists say that in a very denigrating way. I don't want to do that at all. But there is a sense in which, as you push down, you kind of push down from biology to chemistry to physics. So I think that basic search after foundations explains both of those interests.
Maybe we can press into that question you just referenced, which is the concept of reductionism and the occasionally overweening claims that physicists are apt to make about how everything reduces to physics. And this connects to the concept of emergence, emergent phenomenon, emergent properties. The mind is generally thought of in science as an emergent we're building, and the software remains to be seen. But to mind. But how do you think about reductionism and emergence, in particular with respect to causal powers? For instance, if we say that something is a higher level phenomenon, is an emergent phenomenon, if it has causal powers, and so for instance, we're using our minds, we're using language, we're perceiving the world at this moment, this is all considered to be emergent, on the basis of, to supervene on the basis of, neurophysiology and its micro events. But if it has causal powers, if my understanding of English grammar, say, or my intention to use a certain word in this sentence has causal powers, doesn't it only have causal powers at the level of its micro constituents, which is to say at the level, at bottom, at the level of physics? Doesn't the reduction actually run through, even if we can't conceive of, much less explain, higher level phenomenon in terms of their micro constituents, which is that we're never going to actually be able to think about things like conversations or stock markets or cocktail parties or anything else in terms of the subatomic particles and fields of electromagnetism. But aren't the causal powers of those higher level phenomenon nevertheless reducible to their micro constituents?
Okay, so there are a lot of words you use that are multiply ambiguous, and so it's very easy to get lost in this thicket. Among those are emergence, supervenience, explanation is going to be a big one here, and causation. And part of the problem is that even in the philosophical literature and in the physical literature, people can mean literally diametrically opposed things by emergence. So there was a time when some of the so-called British emergentists, the hallmark of emergence was a phenomenon that could not be explained on the basis of microphysics, couldn't be accounted for, and was fundamentally novel and only emerged at some time or in some systems or something like that. But my view is that the supervenience claim, as far as we know, is true for what we call the ontology. That is, there's a certain sense in which my computer, just to take the example I'm about to give you, my computer is nothing but a collection of atoms put together in a certain configuration. And everything it does, we think, in principle, could be accounted for by just studying how atoms interact and how electrons interact and then how this whole very complicated gadget is put together. But let me just give you an example I use a lot. So suppose I've got my computer, it's on the table, and there's a little display of spinning rainbow colors going on, coming off the screen, photons coming off the screen. And I call in a physicist, kind of a super physicist, and I say, can you make a prediction about this display? What's going to happen? And you imagine the physicist could kind of scan the thing all the way down to its microstructure and do some calculations and say, well, that little spinny thing is going to go on for the next 4 years and 5 hours and 47 seconds, and then the screen is going to go blank. And I say, okay, thank you very much. And then I call in a computer scientist and I say, what's the deal with the screen? And the computer scientist doesn't even look at the computer, looks at a bunch of papers that are sitting next to the computer that is the program I've just programmed the machine, and says, look, you got a loop here, right? Step 10 says go to step 12, and step 12 says go to step 10. That little thing's going to spin forever because you're in a computational loop. Now, in terms of the actual prediction, I take it the physicist will be right, because in 10 years and so on, the computer screen is just going to burn out. And that's not the business of the computer scientist to predict. I mean, the computer scientist is dealing with the system using a different set of analytical categories. But I would claim that the computer scientist has actually given me much better information or understanding than the physicist does, right? If the physicist has just ground out a very long calculation on the basis of its physical structure, it may give me good predictions, but it sort of gives me no real insight of the kind I wanted. So to that extent, these other categories that we use to understand the world, including biological categories, computational categories, economic ones, as you mentioned. I mean, the basics of economics presumably would not change if you changed fundamental physics, as long as there were people or creatures that wanted to exchange goods and that had more or less the same psychology that humans have, that they're greedy and they're trying to make money. Then all sorts of economic explanations for why things happen would be unchanged. by even radical changes in physics at the lower level. So the idea that all explanation or all scientific understanding reduces to physics, I think that's just plainly wrong. And in fact, disciplines other than physics are much broader because they would continue to have explanatory power, even if the physics were quite different. But nonetheless, my computer really is nothing more than a bunch of atoms put together obeying the laws of physics, right? There's just, in terms of what it is made of or what it really is, that's what it is. And there's a sense in which the physical structure accounts for everything else that it does.
I think what I hear you alluding to is what often goes by the name of functionalism in the philosophy of mind. I guess we could take it more generally than that, which is, and another way to come at this is to distinguish the software and hardware layer of your computer or many other things like minds. And we could acknowledge that any physical instantiation of a certain function, let's say a mind or a stock market or anything else, that physical instantiation does in fact reduce to physics, but it has a logical structure that can be implemented in multiple instantiations, even as you say, in conditions where the laws of physics are different in important ways. And certainly, even within our world, where the laws of physics are the same, we know we can implement, let's say, a calculator on highly non-analogous physical substrates. And we can do arithmetic with the wetware in our heads, and we can do arithmetic in silico on a computer. And the same logic can be implemented very differently. But in each instantiation, what happens next, and the causal properties of of each sequence of events is a matter of what the physics is doing, but it can't be understood at that level. You can't look at a collection of atoms in a computer and a collection of atoms in our heads and extract the rules of arithmetic from those two different systems, even if each is implementing the rules of arithmetic. Does that get at what you're saying?
Yeah, something like that. Or again, to go back to your own example of the stock market, you've got a broker sitting there, and he's either going to press the sell button.
Hey.
And again, theoretically, a complete physical.
What's up?
What's up? What do you want to talk about?
What's the topic about?
Do you know quantum mechanics?
Yeah, I know quantum mechanics.
Do you know quantum entanglement?
Yeah, I have heard about it.
What do you know about it?
Yeah, I just know about that, like simply, that photon shit.
Mm-hmm.
You know what I'm saying?
Like
I know physics, like Heisenberg's principle, like that shit.
No, Heisenberg, I don't think has anything to do with entanglement.
No, I'm saying about the quantum mechanics basics.
Yeah. Quantum mechanics in general is, it's very wide. I'm just interested in quantum entanglement, nothing else. Everything else is simple. Quantum mechanics is straightforward, but quantum entanglement is a little weird. I need to figure it out.
Like in quantum entanglement, like there's like
I can't hear you.
The particle. Like in quantum entanglement, there is that shit like particle generating, like that.
No. Quantum entanglement is when you have two entangled particles, like when you create two particles, when a particle decays and turns into, and it decays into two particles, each with opposite spin.
Okay, I got it. Yeah, I got it. It's like, about the quantum numbers.
No, what do you mean quantum numbers?
You don't know the magnetic quantum number.
What do you mean?
You know that?
What? No, I don't know what you're talking about.
I'm talking about quantum numbers. They are like 4 quantum numbers.
No, I don't know any. Never heard this term, quantum number.
Really, like, listen. Like, there is spatial quantum, there is principal quantum number, there is angular momentum quantum number, there is magnetic quantum number, and there is spin quantum number. And so this section came into that quantum number, like spin. You know what I'm saying?
No, I don't know. I don't know what you're saying.
Actually, yeah, you just mentioned the spin, and I remembered it.
Mm-hmm.
Yeah, of opposite spin, I think. Like the particle gets decayed into 2 other particles of opposite spin, is it?
Yeah. A particle decays into 2 particles with opposite spins. And then
like, isn't it?
What?
I think you are stating about the electrons. Like it.
Yeah, it could be an electron. Yeah, it doesn't have to be, but it could be an electron. There's other particles that spin, not just the electron. So you create. Yeah, you could create an electron and a positron. and send them each on its way, and then measure one. By measuring one, you can then predict correctly the measurement of the other, which is bizarre.
Oh, you're stating about that. You are stating that. Oh, it's that. I don't remember it. It's. I know which scientists gave it, but I don't remember it, bro.
What?
You just said that. Like we can calculate one's that velocity and one's mass.
No, I didn't say that. I said you can measure one of the entangled particles, and you can then correctly predict the measurement of the other, which is bizarre.
Measurement of which thing, bro? Measurement of which thing?
Measurement of spin.
Of spin.
Yeah. You put it through a magnetic field, it either goes up or down. Once you've done that, you can 100% correctly predict the measurement of the other particle. If you test the other particle for, put it through a magnetic field up or down, it's going to go in the opposite direction.
Okay, I got it. But we cannot simultaneously. We cannot know the spin of both of them. Is it?
Yeah, you can simultaneously test both of them, and there's no problem with that. You're allowed to test the spin of both of them.
That's good.
So you've never heard of it?
Yeah, I heard about the quantum entanglement.
So how do you think it works?
I think that's how you explain, which simply there are multiple particles that are simply linked.
I can't hear
with
you.
Each other.
You're like whispering. Why are you whispering?
Listen. Now you can hear me.
I'm listening, but why? I'm asking you, why are you whispering? Why are you not speaking normally?
Bro, I am speaking normally. Can you listen to me now?
Yeah, go ahead.
Yeah, I'm saying that it's like simply a quantum entanglement. The particles you stated, like they are linked with each other in some way,
No, I don't know. That's my question. How would that work? So if you measure both particles in opposite directions, they are 100% entangled. If you measure them 90 degrees to each other, they're completely random. If you measure them 30 degrees to each other, then you get they are more correlated in the test. They are more correlated than they should be by any method you can think of. He's gone. What a waste of time. Oh my god. But it's good that I'm unable to quickly explain the problem.
Specification of his brain should allow you to predict where his finger's going to go. But for all that, you might say that gives me no insight of the kind I wanted, right?
This is a complete waste of time conversation. Sam Harris is a loon. I used to have respect for him, and I no longer have any respect for him. Mock debate on time. I don't care about time. Time is boring. Crisis in theoretical physics. I don't think I've ever heard this.
Why the foundations of physics have not progressed for 40 years? Why isn't fundamental physics making great progress? When did fundamental physics progress go from a serious quest for truth to a financial racket?
Oh, I probably heard her. I just never heard of independent physics.
Physics has done very little for like 70 years, and it's disappointing. I think people need to think outside the box more.
The last progress made in fundamental and theoretical physics, understanding progress as successfully verified and confirmed theories or models, can be traced back to Peter Higgs' prediction in the 60s and the development of the foundations of quantum chromodynamics in the 70s.
the elaborations on the standard model, which is our.
I can easily fix all these bumps he has on his face. Why does he not get rid of them? It's so simple to get rid of them.
Specific understanding of the world in which we live has been all but stalled from the theory side since around 1973, 1974.
The year in 1973 is claimed to be the date when progress in theoretical physics stalled, the year in which asymptotic freedom was proposed. This long-lasting lack of progress in theoretical physics has not happened in the history of physics since at least the 18th century.
So you're in the top 10 list right now. Top 10 physics things in the last 7 years.
Other areas of physics, such as experimental or
spin 1/2. Let's see.
This is a demonstration of spin 1/2 applied to a continuous electron wave function. Here we have the real part of an electron wave function with 12 wave cycles wrapped into a continuous loop. Now we've added a black helix wrapped around the wave, representing the complex electron wave function with constant magnitude.
This is not really the wave function. I mean, okay, but let's listen anyway.
And linearly increasing phase. Taken all together, this represents our continuous electron wave function. So far, this is just an ordinary continuous wave without the spin 1/2 property. That is, if we follow the wave through a full loop, it connects back to itself because the loop contains an integer number of wave cycles.
What? What are you talking about?
This is just an ordinary continuous wave so far. But now...
It's not an ordinary wave. It's a standing wave, and you need to explain how it's standing. And the answer is this. This is basically how it is standing.
We will give our electron wave function the spin 1/2 property. Now the loop contains 12.5 cycles of the wave, so it takes 2 passes through the loop to connect back to itself. Let's follow the wave through the 2 full loops so we can see the internal interleaved structure. At the end of the first pass through the loop, the wave has completed 12.5 cycles, and it does not connect back to itself yet. The wave has to continue through a second pass of the loop to connect back to itself. That is spin 1/2 applied to
That's interesting.
a complex electron wave function. Here are the 2 full passes through the loop again.
Interesting. So the wave itself, it's not just the spin that is 1/2, but it's also the wave that is 1/2. I mean, the wave itself, it doesn't complete a full cycle on itself. That is weird. I don't know if that's true. You see this. How do you explain this? How is this possible? Maybe it is possible. I don't know. Actually, this now looks more like a standing wave. In a standing wave, you would have this amplitude going up and down, and this is a node. It's always 0. But what is spinning? I don't understand what is spinning.
Here we are showing the case of spin minus 1/2, which has 11.5 wave cycles in the loop. Here's a comparison of the ordinary continuous wave function, spin plus 1/2, and spin minus 1/2. And here's a simultaneous view of all 3 cases. Here's an alternate way of viewing the spin 1/2 wave function. Instead of viewing it as a single-valued wave, which must go around the loop twice, we can view it as a double-valued wave, which goes around the loop once, such that there are an odd number of half cycles of the double-valued wave. Here's the special case where the simple wave has 0 wave cycles. The spin 1/2 case has a half cycle in the loop, and the spin minus 1/2 case has a half cycle in the loop, but in the opposite direction.
What's the smallest thing you can think of? Maybe a penny or a button? How about a Cheerio? Its height is about half of a centimeter. For comparison, there are 100 centimeters in a meter. Let's go smaller. A grain of
Jesus Christ.
thing you can think of. Meter. Let's go smaller. A grain of salt. This is about 0.3 millimeters. There are 1,000 millimeters in a meter. And even smaller. Bacteria are only a few micrometers. There are 1 million micrometers in a meter. A virus is about 20 to 300 nanometers. There are 1 billion nanometers in a meter. The diameter of DNA is about 2 nanometers. The size of an atom is only a few angstroms. There are 10 billion angstroms in 1 meter. When you think of an atom, you probably picture something like this. On the outside, you've got electrons that have a negative charge. In the middle is the nucleus. It's made of neutrons which have no charge and protons which have a positive charge. This model is a good starting point, but there are a few things here that don't quite agree with modern science. For one, the size of the nucleus is a lot smaller than this. If I animate it to scale, you wouldn't even be able to see it. The same thing with these electrons. Another thing that's inaccurate is that electrons orbit the nucleus just like a planet orbits a star. Unfortunately, this is still taught in many textbooks, but it's just not correct. Let me cover some background first. Over 2,000 years ago, ancient Greek philosophers had this idea that everything was made of tiny particles. They called these tiny particles atoms. It wasn't until the 1800s that we finally started using science to prove that these atoms really exist. First, we thought atoms looked like this: a positively charged sphere with negatively charged electrons floating around it. Then we learned that this positively charged sphere was actually a lot smaller. We call this the nucleus. Slowly but surely, we learned that the nucleus is made up of protons and neutrons. These electrons were tricky. At first, we thought they have to be doing something, so they probably revolve around the nucleus like this. Electrons were then discovered to have different energy levels. We call these shells. Shells can only fit a certain amount of electrons. The more electrons, the more shells. It didn't take long before we realized that these shells don't determine how close the electron is to the nucleus. As it turns out, electrons are a lot more unpredictable. So if electrons don't orbit the nucleus, what do? Let's start with an idea of an orbit. Here we have the Earth going around the sun. If the Earth is here today, we can use the laws of physics and gravity to predict exactly where the Earth will be 3 months from now. We know both where the Earth is and where it's going. Now let's go to the size of an atom. With an electron, things are a little different. We can't know exactly where it is and where it's going. We can only know one or the other at any given time. This means it is impossible to really know what the electron is doing. The best we can do is predict where the electron will be found. This area is most commonly known as the electron cloud. However, if we want to be more specific about where to find electrons, you'll need to know about orbitals. This is not the same as orbit. Orbitals are specific shapes where electrons live in. If you were in a college chemistry class, you'd be studying about how these orbitals fill up as you get more electrons. But I'd like to keep things simple for this video. So in short, electrons are uncertain. We can't know the path that they travel, only that they'll be found here in the electron cloud. So now you know that even though this is a popular way to represent an atom, it can be misleading. Just to recap what we learned, everything is made of atoms. Atoms are incredibly small. The nucleus is even smaller, and electrons don't orbit the nucleus. Their path is unpredictable. Thanks for watching, everyone. My name is Jared Owen, and I'll see you next time.
Yeah, I don't know. I don't know. Everybody says that, and I don't understand it. So cool story, bro. Mm. Mm-hmm. Hmm?
Well, here's a question. Do you think that Hamas intentionally fights to induce civilian casualties?
Yeah, no.
Both parties do. Okay, so you're not willing to admit that. You don't live in reality. Like, I don't know.
No, how dare you resist our oppression of you?
October
Right?
7th was not resistance. That wasn't resistance. That was like mass slaughter rape of civilians. That was not resistance. What do you mean? October 7th was not resistance.
Look, I mean, this is absurd.
Zionism today means Jewish supremacy between the river and the sea. There's no other way to describe it.
Today, I'm hosting a debate about the war in Israel with host of the Young Turks, Cenk Uygur, social media personality.
Mm-hmm. Hello, Alaska man. Yes, Alaska.
What's going on?
What's going on? What do you want? Mm-hmm.
Who's the host? Sorry, I just joined.
Yeah, you both just joined.
Oh.
What do you want to talk about?
Nice, bro. Nice.
Mm-hmm.
Mr. Slave.
Yeah.
Who's that on your profile picture?
I don't know. I guess it's an AI. I don't know.
It looks like I think I know that's an actress. That's her name.
Just some Yonkers, man.
No, I know who it is. I know who it is. It's an actress. I recognize.
No.
Anyway, so let's talk about what are your beliefs, man? Are you religious? Are you
Boring. Wait, I want to ask a better question. Do you think that there is similarity between Kamala Harris and Elon Musk? Because I think they're both equally unqualified and got to their positions by failing constantly and somehow just having the right connections through luck. And neither of them should be able to have the power.
Well, one is a DAI hire and rated the lowest favorability in their department, and the other is a billionaire. So I think they're vastly different.
Wait, who's who? Which one's which?
Oh yeah, which one is which?
I think you know which one's which.
Kamala is the richest person in the world. We just
Yeah. Oh yeah.
So you think
Kamala's the richest person in the
so
world.
you believe
Billions
Elon?
of dollars.
Wait, you believe Elon Musk failed upwards to become the wealthiest person in the history of the visible universe?
Yes.
Okay.
Yes. Yes, I do.
He failed upwards, bro. Failed upwards. Gotcha.
You don't fail upwards all the time. You just have to have the right connection. Charming, right?
No. Failing usually negates that you fall down, right?
Well, no, that's why failing.
It's a falling. You can't fail whenever you succeed. That's retarded.
Well, so the idea being that you can be shitty and bad at everything you do and still like
Yeah.
succeed.
Okay. Well, then that's a better explanation. Don't just say fail upwards. That's like what?
Okay, so
Well, that's
Spooky,
just a short way to
Spooky
explain to
Duck,
describe it. Right?
Spooky Duck, let me guess, you're a communist.
Hey, that's a good
Oh
guess.
my
Yeah.
god, dude. Oh my fucking god.
Okay, but that doesn't matter. I'm not even talking about that. That's
It
not
absolutely does matter, bro.
Yes,
I
it
hope.
does.
Oh my
You're
god. Please.
basically, that's all you're saying. You're just yelling
No.
from the top of the rooftops. I'm a
Oh,
communist.
he didn't work hard, guys. He did not work hard.
I
Like,
didn't say
shut
that.
up.
We're talking about qualifications. I think people
No,
make the same argument.
no. We don't need to talk about anything. We need to talk about communism. So, you think
I don't want to
communism?
debate that. That's
What?
we're asking you. I was asking you. That's the AMA, man. You're the host. I was want to ask you a question.
Oh, go ahead.
Right?
Mm-hmm.
I don't want to debate communism. That's boring. I want to talk about this.
Okay.
Elon Musk and Kamala Harris, both unqualified, unexperienced with what they're doing currently in the government, and yet one is hated for being inexperienced and one is not. And I'm curious because Elon Musk doesn't even officially have a degree in anything in engineering or anything. He's not like educated. He doesn't know what he's fucking doing. He's just got a bunch of money. And Kamala Harris is like what? She was a lawyer for a while, and now she's supposed to be president after like a month of just finding out. Like, of course it's gonna suck. So how do these two? Why is one bad and one good?
I mean, we can discuss one of them. I don't see the point of discussing both of them.
I guess I was just wondering if there's like, do you see a difference between them?
I usually don't compare. I mean, I usually don't discuss people. I usually discuss things. So
Okay, I know it was. It's more of an abstract because to me there is a connection I see between the two, and I was wondering if you. I mean, it sounds like you actually like Elon Musk, so maybe it was a presumption. Maybe I shouldn't have just come in and made that assumption about that.
I mean,
do you like Elon Musk?
I like Kamala, and
Oh, you like?
I like everyone, and I hate everyone. Depends,
I
depends.
mean, okay, but I mean, like they're, you know what I mean, like their work, what they're doing,
Yeah.
Do you think Kamala Harris is a good leader, or well, I guess it doesn't matter anymore. But I mean, she's still vice president for another month or so, whatever. Do you think she was a good vice president?
That's a good question. Well, we need to always compare to something. So, compare to what?
Well, I would say based on your. I mean, are you American?
Yes, I'm a proud American. Yes.
And did you vote for the Democrats when in the last?
I cannot disclose any personal information.
I mean, in 2020, like not like the election that got.
It doesn't matter. It doesn't matter. What's the question?
I guess I want to know if you would support her, or do you support her as a politician?
Compared to what? Who was running against her?
I mean, do you support her policies or her platform?
Compared to what?
Not compared.
I mean,
it doesn't. It's not about the comparison. Just like, do you support what she's saying?
Like what? Which policy?
Well, I mean, her platform, her party position, like the way she tried to.
I don't
make
even
Democrats.
I don't even
Really?
know. Like I heard once that she wants price controls.
That was one thing for groceries, right? Yeah.
Yeah, so I think price controls are one of the worst things you can do in an
Okay.
economy.
Even right now?
Always. There's no exception.
Even like during like historical levels of like price hiking and your like basic needs on rent and food, do you think it should just be allowed to just continue?
I would say especially in those times. But yes, in general, yes, correct. I think price control is terrible.
Why?
I mean, this you don't want to talk about communism, so this is just basic economic theory. This is
It has
when
nothing to do with communism. This is just regulation.
I mean, this has to do with basic economics. This is
Sure.
This is first day of introduction to microeconomics.
Yeah.
So you learn that basically if you fix the price, then you're going to create. I mean, depends on where you fix it, but if you fix the price too low, under what's known as the equilibrium price. So if you fix the price too low, you're going to create a shortage. That's why there's usually shortages of goods under communism.
Well, that's not the case right now. It's the opposite. We waste.
Okay, I'm just saying.
So
yeah.
So why not? We should be able to do some price control then, right?
Yo, what up, people?
I see. No, you're not contradicting me. So I said that fixing.
You're making it sound like your principle, like you have a principle in general that's against price control when you don't have to look at it as black and white. You can have some price control because right now a lot of food's being wasted because people aren't buying it because they can't afford it or whatever. So it ends up in a landfill. So if the government stepped in and forced the prices down, people would be buying that stuff that ends up in a landfill, right? That's basic economics 101 too.
No. So
No?
No. Basic economics says that. I mean, I don't know already if this is basic economics, but probably within first semester, intro to micro, you should cover the mathematics of an equilibrium point. The definition of the equilibrium point is that supply equals demand. It's also
Well,
called.
there's
Mhm.
sure, but you know that it is supply and demand even on its own is a very simplistic way, and there is no real equilibrium point. These are all abstractions. They're not. That's never the case. You'll never reach the equilibrium point, and supply and demand are incredibly naive ways to describe reality, right? I mean, supply and demand are not real, right? That's not how the real world works. It's a really simple way to describe things, right?
No.
Oh, you disagree. Okay.
Mm-hmm.
Well, okay. This is maybe you can. Okay, so I know a little bit more about economics than just economics 101. So maybe you can explain to me why I'm wrong.
Ask me a question. I mean,
Well, why am I? What is wrong about the idea that supply and demand is a simplistic way to describe economies? Because it is in my opinion, it's a very simplistic way to describe economy.
I don't know what to say to that. So you need to ask me a question so that I can answer. I don't know. I don't know what to tell
Can
you.
you give an example? Can you give a counter example to can you give an example of you're right. Okay. You're right. I'm trying to make a counter argument without giving you an example. If we look at how a country's internal economy works versus how the international economies work, you can see, for example, that supply and demand within a country is not going to work if there are outside influences, right?
No.
So you can't analyze a local economy when you have external economy. You can't when there's a local international, grows, right? So nothing is in a bubble. No economy is in a bubble. So you can't just look at things in terms of supply and demand because there's always going to be external factors, right?
I said no, and you ignored me saying no. You asked me,
No,
and
no.
I said no. And
I know. I'm okay. So if you still disagree with me on that, then I guess what I would have to ask is, uh,
you're just
how
asserting.
does the locally?
You're just
No,
making.
I know.
Mhm.
I know. I'm making assertions. I'm trying to figure out. We have to agree at some point because so far we disagree completely. So I'm trying to figure out where we agree. If you disagree with that, do you believe that a local economy can be completely isolated and work internally on its
Yeah.
own?
Yeah, but that's
Can
not.
you give?
I mean, it could be, but that's irrelevant. I mean, planet Earth is completely right. It has its own economy. It doesn't depend on the economy of the Andromeda galaxy, as far as I know.
No, sure, but as far as we know, there's no like the Andromeda galaxy has no influence on. You're right. So the Earth, I guess the planet Earth right now is an enclosed economy. What about like a small village?
What's the difference? Why should there be a difference?
Well, a small village can't be fully self-sustaining, even if they are able to farm and produce their own electricity, whatever. A government regulation is going to cause trouble if they're breaking the law and the police roll in and start causing troubles, right? I mean, this happens all the time. You can't
Look,
base an economy on the idea that you can be self-sustaining, right?
look, you're monologuing. So and
I'm trying to find like some
Mhm.
common, like some starting point for a conversation. That's all. I'm not trying to monologue. I'm trying to
so
find something.
so if you really want to talk, I don't know what it means find, but if you want to talk, then you have to use shorter sentences. And when you ask a question, you have to stop and wait for the
Okay,
answer.
but you are the one who said you want to have a more nuanced conversation about economies. So I'm trying. That's why I'm speaking a lot. I'm trying to find like a nuanced conversation.
No, you're
I don't
not.
know. Okay. All right.
I just said no.
What?
I just said no, you're not. Right? You keep making assertions and you disregard you completely ignore all of my responses. So that's not having a conversation.
All
No,
right.
and when you
Okay.
ask me questions, you never wait for the answer ever. And I mean, with minor exceptions. So, I mean, I'd like to have a conversation, but you need to change your etiquette.
Okay. Well, then maybe you, as the host,
hmm
can start the conversation, and I can try to engage that way.
I actually prefer the way you were going about it. Just as I said, when you ask a question, wait for a response.
No,
And
because you keep telling me to make an assertion, and I'm trying to, and then now you're criticizing me for talking too much. What am I supposed to do?
so, wait. So it's okay to make assertions. It's okay to ask questions. Everything is okay as long as you you inhale or exhale mid sentence or quarter through a sentence and let me interject so that we can have a ping pong.
Well, I would like to be able to finish my point before that, because I hear I'll be and to make my retort here. I've been trying
hmm
to get the conversation started by putting many different points out there, and you have been constantly denying it or saying it's not relevant or poorly made or not interesting or not relevant. So if you're accusing me of talking too much, it's because I'm trying to start a conversation and you're not engaging. You don't want to engage with half the things I'm saying. So I'm just not sure what you want to talk about.
No, 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 no. No, everything you've said is extremely interesting. Even when I said it's not interesting, I meant technically, it's not technically interesting. The conversation is fascinating. I love talking about economics and I love talking to communists. So, but I'm just saying, like, try to have, like, when you said you want to finish your point, try to not finish your points, because you're not the first communist. Go ahead. Mm-hmm.
Okay. Don't fixate. You asked me if I was a communist, and I said yes. I'm not trying to assert anything about communism.
Okay.
I'm getting the opinion here now. You are characterizing me based on something. Do you go to Reddit very much?
Do I go to Reddit?
Yeah.
No. I actually I I get Reddit pregnancy. I don't know why I keep getting notifications from Reddit pregnancy, and it's actually very interesting, but that's all I get basically. Pregnant.
Wait, Reddit
Reddit
pregnancy?
pregnant. Yeah.
What is that?
That's the subreddit that I probably registered for to get notifications, and it's really active. And
The pregnancy Reddit?
pregnant. It's called,
Do you have a family or do you have kids?
I don't disclose that information, but I
Okay. Okay.
find
Well, this is strange. It seems strange that you would. That one in particular doesn't seem strange.
I was about to say, no, I probably registered for pregnant because I love pregnant women. I find pregnant women extremely sexy. But
Okay, well, you shouldn't go to a actual. Okay, that's not the place. Come on, that's weird. That's creepy, right?
No.
Not have. I get it. Like I understand kinks and shit, but you gotta go to a place that's for that. Like, isn't there like a sexy pregnant women subreddit? Don't go to one where it's like actually normal pregnant women who are just talking about it. That's weird, right?
No.
Sorry, I didn't mean to turn it that way. I didn't mean to turn this conversation. Okay.
But listen.
Anyway,
no, listen. So you said that's weird, right? You put a question mark, and I answered both times, and you steamrolled over my answer each time. You
because
never.
you don't
Look.
listen. You don't
We're not
listen.
having a. But you either want to have a conversation or a lecture. So if you want to have a lecture, then post your lectures on YouTube and send me a link. I might, listen to them. Probably not.
Okay. You want to talk about communists.
I want to have a conversation. We can have a conversation about whether or not it's creepy to get notifications on Reddit for pregnant. We could have
That's
a conversation.
very creepy.
Yes,
Extremely creepy.
and I heard you say that twice, and twice I said no, it's not. We could have a conversation about that. We could have a conversation about anything, but you need to stop steamrolling over my answers, because it's just going to be a very boring, not conversation.
Okay. All right. So far, we haven't even found a topic. The reason I asked you about Reddit is just because I felt like you were categorizing me and talking to like a personality in your head that's not me. Because sometimes you say things that it's like totally not. I don't know. I feel like you're just not talking to me. You're just kind of used to. You have an idea of like I'm a type of person, and you just I don't know. Anyway, let's have a real conversation.
Why are you blocking friend requests?
Because a lot of freaks are on the server.
Well, I find you interesting, so why don't you send me a friend request so we can be in touch?
I just don't think I shall. But maybe if we have a good conversation.
You don't feel that our conversation thus far is interesting?
I think so far it's been you attacking me from the way I conduct conversation, so it hasn't really been that.
So you're gay?
Great. Yes.
Mm-hmm. Are you also trans?
Sure.
Mm-hmm. Okay. Go ahead, continue.
Why are you asking those things?
You seem to be extra sensitive. You're not. That's not normal guy. You're not. What you don't like a normal guy would be more rough on the edges. I think you're more sensitive on the edges.
Yeah, I am emotionally sensitive, but that's only because I know how to handle my emotions. I don't think people really understand that like acting tough doesn't make you tough, right?
Yeah, I'm the same. That's good. I'm not gay, but I'm the same. Yeah.
Yeah, it also doesn't make you gay to be able to feel emotions. Like it's not relevant.
There's nothing wrong with being gay. I
No,
happen.
I know you're not saying that, but like this is, I mean, let's talk about that. That's actually an interesting topic to me, and maybe you'll be interested too. Masculinity.
Okay.
Do you think being emotionally sensitive is masculine or not?
I don't even know what it means to be masculine. My fantasy is
Okay.
to be emasculated. I
Okay,
mean,
you don't need to say that. You don't need to say that. You don't need to share that.
why?
Like, nobody needs to know your
Wh-
fantasy.
Why does no? What
No,
do you? Why? What's okay?
you don't need to tell people your fantasies
Why not?
ever.
What's wrong with you?
Just please don't do,
I'm
don't do
sorry.
that.
Okay. Okay. I don't.
Not
I don't. I mean, I don't even know. Like, if a guy is manly, I don't even know. I'm a manly man. I'm very manly.
Are you sure?
Yes, I'm very manly. That's why I fantasize about being what you don't want to hear. It's a fantasy
Yes.
because in my real life, I'm very, I'm in control. I'm emotionless.
I don't think that's how it works.
I
Do you
think.
think that because it's a fantasy, it means that it could not be? Okay, that's great. I've never heard that. You think because you fantasize about it
It's
and
a
it's not a
theory.
reality.
It's a theory. It's a
That's
theory.
crazy. Okay. Oh my god. Wait, you're American? Did you say you're American?
Yes.
No shot. You're not American. You don't even
Not.
sound
I
American.
was not born in America, but I am.
You're from the Balkans, I'm gonna guess.
It doesn't matter. I do my best to remain anonymous, so I'd rather not discuss anything that might.
I come from Serbia, former Yugoslavia. I don't know, your accent
It
is telling
doesn't
me.
matter. We're not discussing anything that might get me doxxed because people are trying to kill me. I have active life threats.
Well, I knew it. You are from the Balkans. Now I know you're from the Balkans.
Very good.
Well, look.
Fantastic. Let's continue the conversation. Not about me. Let's talk about anything else.
That it is an important context because it now informs me like
No.
why you have a certain perspective of what it means to
No.
how to express yourself, right? No, it's true. There's cultural differences, right? It's not even about masculinity at that point. It's just about how you express yourself. You know, a lot of Eastern Europeans.
No, I keep saying no, and you steamrolling over my answer. No, stop steamroll. Do you know what it means to steamroll?
Can I'm not allowed to just like you can't just say no and then I have to stop talking.
Then what kind of a then you don't want to have a conversation. You just want to talk. That's not
no, I want.
You're supposed
The
to.
way a conversation works is one person has a turn to talk, and then the other person has a turn to talk, right?
No.
As soon as I start talking, you start saying no. It doesn't mean I have to stop talking.
Yes, it does. You have to be more sensitive to the needs of your.
I thought I was the gay one. What
Not gay enough.
God damn it!
You need to go through
All
my
right.
sensitivity training.
I guess so. Okay, wait. That means you're probably not from Croatia. You must be from Bosnia.
Oh my god. Okay, you're just guessing. Stop guessing.
You are. I knew it. I was right.
Stop. It doesn't matter. Let's continue. Let's talk about not me, please. You know,
Okay. All right.
every conversation on Discord, I end up, the whole conversation is me begging the other guy not to talk about me. That's the whole conversation.
Well,
Always.
you need the room. Ask me anything. Now I'm not supposed to ask you anything.
Yeah, not about anything but me. That was the intent. Yeah. Anything
Well,
that
look,
is
you
not
live.
me.
Okay. All right. All right. But yeah, look, obviously, what are we gonna talk about then? What are we gonna talk about?
Oh, just that little thing called the universe.
The universe. That's a big topic.
I know. So you're you're like, we have nothing left to talk about since I'm off the table, except for that little thing, yeah, that we still
No,
didn't
I think
cover.
I, I thought it was just funny. I was able just to figure out.
What?
Anyway, it doesn't matter.
Yeah, it's yeah. Everyone tries it, so for me, it's boring.
Yeah, I know. I mean, obviously, no one wants to know you're from Bosnia. But do you have
Ah,
like?
do I have what? Do I have 4 legs? Yes.
Oh, do you have a?
I have 5 legs
Okay,
and 7
you found out.
ears. What?
You asked me about you were interested when I said I was yes, I am a communist. So let's do that.
We can
Let's
do
have that
anything.
conversation.
We can also talk about many things. It's up to you. Go ahead. I'm listening. What's the question?
Okay, I have a question. I read a book this year called The Black Cloud by a author named Frank Lloyd. It's about a cloud that moves into our solar system and covers the sun and blocks it out. And so the Earth sends out a rocket to go investigate, and they find out that the cloud is intelligent and it can communicate with human lives, and it has demands, and it wants us to worship it like a god, and it will only give us light if we do certain things. And so the whole point of the book is about how this one cloud is like just as powerful as God. It could be God if it wanted to be. It's just here to visit. So it's a thought experiment because this is a book that was written in the 70s, as America's space exploration was growing. And so it was an idea of like what could happen if this happened. But I was thinking about spiritually, there's no reason to believe that this exists, and maybe that is God, right? Maybe God is something like this, right? What do you think?
So everything you said is wrong and very boring. That's what I think.
Okay.
So you ask me a more detailed question.
Do you believe in God?
How do you define God?
Are you a Christian?
I don't disclose that information.
Oh, okay. Do you follow any?
No, we're talking about the universe that is not me. That we're talking about.
How are you supposed to have a conversation when you never tell me what you believe?
Why do you care? Ask me questions about the universe. I'll tell you what I believe about the universe.
Oh, no, I don't give a shit. Anyone can tell me what shit they read on Wikipedia. I want to know what you think. And every time I ask you for your personal opinion, you keep saying I won't disclose it. It's like, buddy, what do you?
You think I'm gonna look up Wikipedia if you ask me? You asked me if I believe in God. I said, how do you define God? And then you asked me, am I a Christian? I said, I don't disclose that information. That's the end of the conversation. You don't know how to define.
No, it's not the first time you've said I'm not going to disclose that. Every time I try to get into a conversation, you keep saying I won't disclose what I really believe. It's like, well, okay, what are we doing? What are we gonna do?
No, I didn't. I never said that.
You did before when I asked you where
Never.
you're from, what your
I
politics.
don't disclose that information. I do disclose, of course, I'm going to disclose everything that I believe, as long as it's not, information that might dox me. So I don't have a
Your
problem.
Christianity. How would you eat doxed if you're a Christian or not?
I'd rather not go into the theory of how to dox someone. That is excruciatingly boring. But
Oh, because you're going to be like, I'm part of like the mixed Russian Greek Orthodox Church that only exists in Bosnia.
imagine
Okay, I get.
that's a possibility. For example, if you need one.
Okay, all right. So
Look,
okay, fine. I respect it. I respect it. It's
look
fine. I respect
about the definition of God. So the question is your definition of God
Riding to New York.
Hey, Stewie, is your definition of
it.
God scientific? Meaning, can we scientifically measure this God that you define? If so, that's like when you say, "Do I believe in God?" The question is, a God that is scientifically measurable? Do I believe that there is a God, there could be a God that is scientifically measurable? Well, I believe in science. So I believe that there could be a measurable God. Now, what would a measurable God be? That's a good question. But there is a possibility that there is a measurable God. For example, a God that created this universe. It's not.
Would you wait? For example, like a counterexample would be there are things that we are pretty sure exist that are not measurable, right? Dark matter and dark energy and stuff, right? Like at least based on physical, what I know about it, I'm not a physicist, but what I understand is like we have things that we can't measure. Like our galaxy has a larger mass than we can observe. There is something else in the galaxy besides the observable matter, right? There are immeasurable things that are contributing to the mass of our galaxy, right?
So the fact that we didn't yet find out what exactly dark matter is, it doesn't mean that it's not measurable. I mean, dark matter is scientific. We define it.
It's immeasurable, like we can't measure it with our current instruments, I guess.
We haven't
Yeah.
yet detected what exactly is dark matter. Maybe it is possible to detect it with our current technology. We wouldn't even we haven't detected it yet. So but we have enough detections to know that something is wrong, probably with the velocities of the outer rims of all the galaxies.
Right.
That's dark matter. And the other one you said, maybe you said dark energy?
Yeah, I mean, I think, dark energy and dark matter are kind of the same thing, right? They're both like just
No.
constant. They're
No.
what's the word?
No. Dark
Well,
energy.
matter and energy.
No. No. Dark energy is very straightforward. Dark energy is very simple. I'm fine with my theory of dark energy, but dark matter, I'm as lost as everyone, basically.
Am I wrong in believing that energy and matter are like in the grand scheme of the universe not any different from each other? It's just about equations.
But these are two different phenomenon. Mass and energy.
Well, they're phenomena in the equations, but in the universe, they're not. They're both like it's like light has no mass and yet it is matter and it only carries energy. It is just a part of a mathematical equation and it gets to exist as a wave and a particle. These are all intuitive concepts. They are nothing but mathematical concepts and they are
dish galloping. You got to slow down.
I'm not gish galloping. I'm trying to give you an example.
Wait, dish galloping or gish down? How do you wait? Is it dish or gish?
Gish. It's G for both. Gish, galloping. G.
What is a gish? I know what a
It's just a word.
galloping is, but
It's just a word. It's one
what's the
word.
word?
And also, gish galloping is more like if I was to be like, you know about matter, and also what about E equals mc squared, and also about how do you feel about Newton's field equations, and also did you know about the Euler's equations, and what about galaxies, and what about did you think about this? If I present like 10 problems to you at once and expect you to answer, that's gish galloping. I'm talking about one thing. I'm not gish galloping.
Well, you're bringing up many topics.
I'm bringing up one.
Well, you just brought up light. Even dark matter and dark energy are off topics. We were discussing God. So from God,
You don't think they're connected?
what?
You don't think that's a connection? You don't think there's a connection between God and dark energy?
But we can finish dark energy and dark matter in reference to God, and then get back to God and finish God, and then move to light and whatever else you want. I am able to answer all your questions except for quantum entanglement.
Okay, I didn't even bring it. The reason I brought up photons is because that's one specific particle in cosmology. We're still talking about dark energy. My point is that they have a unique behavior, a unique set of equations that defines their behavior, and that's all they are in terms of like reality and physics. It's the same with dark energy and dark matter. We just haven't seen it with an instrument, but we have equations that describe their nature and how they fit into it, right? I'm not trying to lead the conversation astray.
But
the whole point is that
you're losing me. I'm honestly lost with your. It's the same. It's the same. It's the same. I mean, I can answer all your questions. I have answers to all the questions except for entanglement, which
I never brought up entanglement.
Yes, and even then, I'm close within 5.6% to the answer. But
Are you a physicist?
No, but everything else I've already basically figured out, or I don't care. Like dark matter for now, I don't care right now. Right now, it's not an issue, but I know we can have a discussion about it. But everything else, anyway. So
Wait, Mr. Slave, I've got a question.
Yes, sir.
Am I okay to ask?
Yes,
Yep.
sir.
What do you mean by ask me anything? Like,
Not
literally
about
anything.
the universe that is not me.
It means it's very hard to get an answer.
Nothing personal. I don't
Oh,
answer
okay.
personal questions.
So, like, literally, like, to do with, like, psychology, philosophy, physics, that sort of stuff?
Yes.
Oh, okay. Fair enough.
Yeah.
Well, so you basically know everything?
Yes, basically.
Oh, shit.
Well,
That's
no,
so cool.
apparently he doesn't even know what country he's from, so I don't know. Is it Bosnia or is it Yugoslavia? He'll never say. But okay, let's move on. Maybe we're not having a good, I don't know. Are you interested in this conversation anymore, Mr. Slave, or do you want to have a different conversation?
It's a terrific conversation. It's good. You're opening multiple threads.
I guess I feel like I'm putting you on the defensive, and you're just you're not enjoying it. So I don't know.
No, I'm very much enjoying it. It's one of my best conversations. It's a great conversation. It's not only good, it's great. I'm really enjoying it. We can continue. You don't worry about it. If I'm not enjoying it, you notice that I will let you know immediately. This is instant feedback.
Okay. Yeah, because you said a gish thing when I brought up 1 point as an example.
As I told
It's very
you, instant feedback.
God, it's very hard. It's very hard to ask you a question because you get very defensive. I'm gonna let Tom T. Ask a question. Go ahead.
Okay. What do you think of Jung's archetypes?
Jung's archetypes. I don't really appreciate Jung. Which one do you want to bring up?
Just like the idea, like the concept of archetypes.
What do you mean? Like, I don't
Do you not know
remember.
what archetypes are?
I mean, let's assume I don't know what you mean. Let's assume that.
Okay.
So what do you mean by
Well,
archetypes?
well, do you know what they mean or not?
I said let's assume I don't.
Right, but you said ask me anything, so I'm asking you, like, do you know what an archetype is?
If you're here to quiz me, then that would be that could be interesting. I'm not here to be quizzed. I'm here to answer questions. If you have a question, if you're curious about the universe, I'll answer your questions. But if you're here to quiz me, that's
Well, no, I asked you a straight question.
yes.
What do you think about Jung's
But
archetypes?
yes, but
And now
within
you're saying, what do you mean by that?
no. Yeah. I'm just letting you
No,
know.
yeah.
Yeah, I'm letting you know. I mean, I'm here to answer questions. I've done my
Okay.
research. I can
So
answer.
if that's what the purpose of you being here is for, why don't you fulfill that purpose by answering my question, which is, what do you think of Jung's archetypes?
Maybe a better way to ask the question to be diplomatic, and I don't want to. Sorry, Tanti, I don't want to talk or like I don't want to be rude, but
Yeah, no worries.
maybe asking like, what is your definition? Like, how do you see it? Like, for the sake of a subjective conversation about what these words mean. Like, when you talk about an archetype, what does it mean to you?
Well, it's like a common pattern of behavior that can be categorized into one idea, so such as like the hero or the a predator, a villain, things like that.
Does that make sense to you, Mr. Slave?
Yeah, a little bit. So, I mean, I think we have. I don't know specifically what Jung said. Jung, as far as I know, is very mystical, and I'm not.
Yeah.
I'm very scientific. I'm very deterministic in how I view this universe. I'm very mechanical in how I view the universe. There's no magic. So in general, I thoroughly abhor Jung, and I like doing a simple Freudian psychoanalysis.
What do you specifically dislike about Jung?
That he's magical. He believes in
Magic.
He believes in magic. He believes in actual, actual magic, literal magic.
Can you be more specific?
Like magic, demons, ghosts, other dimensions.
Well, these are metaphors.
No, not.
Yeah.
What, in Jung, those are metaphors?
Absolutely.
Yeah. And just because they are metaphors doesn't make them any less real.
Well, either way, I don't like metaphors in general. I don't like analogies.
Right, but they still are real. Like they encapsulate something that is real.
Anyway.
Or maybe they describe something that people experience, right? Even if a demon isn't some horrible monster that's like the boss of a video game, it might be something in your head that makes you do evil things or hurt yourself that you end up personifying or recognizing as an aspect of yourself that you don't like or don't want. This is part of psychoanalysis that even Freud talked about, just in his own fucked up way, because he thought everything was sexual. But it's all rooted in the same concept. Your brain has ways of fucking with you. Have you ever heard of a concept of intrusive thoughts, where people think about doing violent things to themselves or other people around them without wanting to? This is just how the brain works, and we try and describe it, right?
Tom, you are a white supremacist, white nationalist Christian, right?
Yeah, that's 100% correct.
Yeah. So that's because you are mystical. You support Putin, and I abhor Putin. Putin is a loser. And
Wait,
so
where did you actually get that from? How did you know that?
from your profile picture.
Oh,
Wait, isn't that a picture of? Wait, who is? Oh, I thought that
isn't
was.
that a picture of me? I thought that
Is
was
it-
a picture of me.
I thought it was. You know who you look like? Do you know what's his name? That leftist Twitch Hassan. Do you know him?
No.
Okay. There's a guy on. There's a big popular leftist communist guy that you look. If that's you, you look exactly like him. I thought that
Oh
was.
shit.
I thought you were.
Wait,
like,
what are you seeing? Because I'm.
I forget. I think his name. Yeah, it's Hassan. Yeah, Hassan.
No, but what are you seeing in my profile picture?
I see you
Am I-
in a tank top
Oh, okay.
with
Yeah.
your
Yeah.
musk.
Wait, so where did you get the white supremacist thing from?
I'm just putting it together. I mean, you're a mystic. You're like Putin. You're like Hitler. You will destroy civilization with your belief in magic. You believe in magic. That's why you love Jung. That's why you like what's his
Oh
name?
my god, that's a lot of assumptions.
What's
That
his
is a
name?
lot of assumptions.
Peterson. You probably like Peterson.
Yeah, I love Jordan Peterson.
Yeah.
I love Jordan Peterson.
He's an idiot.
You do? Oh my god.
He's great.
No, he's not.
Wait. Okay, Tom.
He's a
I
total
just found it.
idiot. He's a loser.
Wait a sec. Let this guy
This is
speak.
the guy I put in the side chat. This is the guy you look like, Tom T. If that's you.
Oh no. Oh.
You look. It's so similar. You got the same hair, the physique. It's so funny. It's
Well,
like
yeah. No, I see. No, he's bigger than me. He's
okay.
definitely
I don't
bigger.
know. I can't really tell. That's fine.
But yeah, I see what you mean.
Yeah, Putin is on the brink. I mean, thank God we have Trump, who probably will.
Oh yeah.
Who probably will
love Trump.
save us, but Putin almost destroyed the planet. I mean,
Wait, so what's your problem with Jordan Peterson?
Oh, I
exactly the same problem I have with you and Putin and Hitler. You're all mystics. You believe in nonsense. You will
my
destroy the
God.
universe.
Can you give an example of some like I don't really I mean I never said I agreed with like Hitler or what's his name Putin. Like you're just strawmanning me there completely.
Yeah, you suck. Confused.
So I mean, go on. What do you disagree with Jordan Peterson?
You
on?
believe in magic. All of you.
Can you stop like putting words in my mouth and actually like state a specific concept that you disagree with him on, not just like magic, like because I could say to you, oh, you just believe in numbers and you don't believe there's such thing as feelings and experience, like, but that doesn't actually get us anywhere. So
I look, you are what I categorize as a mystic.
but you don't even know what I believe. You don't have a clue what I believe. You've not asked me like any questions at all.
I asked.
You've got no idea what I believe.
I told you that. I asked you. I told you that I think you are a white supremacist, a white nationalist, a Putin supporter.
Well, he said he is. He admitted that he is.
No, I was being sarcastic. I'm from the UK. Like that's just what people in the UK are like.
You're being sarcastic.
Like if somebody comes up with an absolutely absurd idea and they just assume it out of nowhere, like because it's funny, like because it's such a ridiculous idea, obviously I'm going to be sarcastic about it.
You know how many people on this server are ready and willing to say, yeah, I am a Nazi and actually mean it? Like, this is not the place. You can't just make jokes about that here, okay? Some people...
No, how is this? I don't understand how he can... So, how am I not allowed to be sarcastic about that, but he's allowed to just, out of nowhere, assume something like that?
No, I'm joking. I think that, yeah, I think if you're being unfair. Honestly, like, he's not. He was joking. Don't be autistic about it, okay? Just chill.
I'm not joking. So, look, you believe in Jung. You believe in.
I mean, I believe he existed.
No, but you.
What do you mean by believe in Jung?
You believe.
What do you mean by belief? What do you mean by belief?
I mean, you brought up Jung out of nowhere.
Right.
So
I could have brought up Hitler.
Yes.
I could have brought up Putin.
Yes. Yes.
believe in the Myers-Briggs category?
These are identical. They all fall under the same category.
Oh my god.
You would have brought up some mystic.
Bro, you're full of shit. You're full of shit.
Okay, do either of you guys believe in the Myers-Briggs categorization of personality types?
I'm not very familiar with that.
What about you, Mr. Slave? Do you know?
I didn't even
you know
hear. I didn't hear what your audio is not as good as
No,
ours.
his audio is pretty good. I can hear him.
The Myers-Briggs test, the Myers-Briggs categorization. It's a 4x4 grid with basically there's 4 factors. Each one has 2 different possibilities. You're familiar with Myers-Briggs, Mr. Slave? You're very smart. You know
I might have taken a look at it once. In general, I don't like I don't like these categorizations that I did not create.
Okay.
Mr. Slave, it sounds like you're the mystic.
Yeah, it does sound a bit like
it.
No, I'm actually.
Where did you get all of this knowledge from?
I'm an old man. I don't sound it, but I'm a very old man.
You sound
okay,
like
well that means nothing because lots of old men have thrown their lives away.
Yeah.
Somebody left.
So I got lucky.
I'm an old soul. I'm an old soul, young body. I'm ready. I'm here to fuck.
Anyway, I got lucky somehow. I figured a bunch of things out. There's a few of us.
I don't think you figured much out.
You sound like you watch a few YouTubers that I might be familiar with.
Who, me?
Yeah.
Everything I watch, I stream. So I usually don't watch anyone.
So you watch Destiny?
No. I've been watching Tim Mullen lately. Professor of philosophy. Science philosopher.
Okay, sure.
Mhm.
Tim Mullen.
Okay, so what do you think about what's it called? Give me a sec.
What's your opinion? Oh wait, sorry. Tom T's got a question.
No, you can ask
It's,
until
you can ask your question first because I just forgot like the word that I was going to ask.
Oh, I was gonna completely change the subject because
It's
I
fine. What's the question?
No, actually, now I think I'm going to show my ass if I ask this stuff. Okay, well, fuck it. What do you think about Israel?
I think it's actually very confusing. So the Middle East is very poor, and that's why it's very violent. And it's very poor because it's basically socialistic. The Islamic nations are very socialistic. And Israel is also relatively socialistic. So the whole region is very poor. And poverty leads to violence.
Israel isn't very poor.
It's relatively very wealthy relative to the region, but Israel
No,
relative
across the world, like compared to the world, it's pretty. I'd say it's quite wealthy.
No, Israel.
So
Israel is literally by far the poorest in the OECD. Israel is by far poorer than Turkey. Israel is extremely poor, and the OECD in general is extremely poor. Let's say compared
What if
to
you remove the population of Gaza and the West Bank? Is
nothing.
Israel?
Nothing will help. Nothing will help.
No, I mean if you look at the poverty rates, if you ignore Gaza and the West Bank and just look at just Israel, I'm sure that the poverty rate's much better, right?
It's
because that's where the conflict is. It's obviously in West Bank and Gaza.
So
right?
here's another complication. The Hamas government in Gaza was artificially created by the Israeli government and funded.
Oh, wow!
And
wow, that's a smart point.
All right,
You
so
actually
Israel has the 13th highest GDP per capita in the world, but it's apparently it's poor. Okay.
no, but what Mr. Slave just said is actually, I'm going to give him 1 point, the first point for today, for actually saying something intelligent, which is that the poverty in Gaza and the West Bank is caused and it's part of Israeli policy. It's on purpose.
It's not. It's difficult to say if it's on purpose. It's a mess. That's more accurate.
No, it's called
I
putting.
mean, if I had like a group of people that wanted to wipe out my civilization, I'd probably want to keep them poor.
It's called putting Gaza on a diet. And they're not allowed to have cookies or chips or treats, chocolate bars, anything like that.
Listen,
allegedly, because
I'm
they
gonna
use them
have
to make pop.
I'm gonna have to
That's why.
sign. I'm gonna have to sign off. I gotta take an urgent call. I'll talk to you guys later.
Okay.
Bye.
Okay.
Bye.
I think the idea.
Bye. Bye.